All right, so I hope this is visible to all of you. And again, we are going to talk about differential equations. In the previous class, we have talked about the basic things about differential equations, how they are formed, what they are, what do we mean by the solution. And then we moved on to something which is very, very important. That is a method, different methods actually, of solving differential equations. We have learned up to the point where we saw how we can solve homogeneous differential equation. So this is the second session and the last session for calculus, and then I'll be moving on to algebra. We'll talk about matrices and determinants, and then we have probability, then vectors and 3D, etc. So this is session 2 of differential equations. So let's see what we are going to study here. Okay, so these are the topics I'm going to cover today. So we learned up to homogeneous differential equations, and then I'm going to start with, following from that particular thing, I'm going to start with reducible to homogeneous equation. Then some non-homogeneous equations, there's a particular form that I will talk about. Linear differential equation of first order. Now this is very important, and mostly you will see questions in competitive exams from this particular part. Differential equations which are reducible to linear form, and then we'll talk about exact differentials, application of differential equations, and differential equation of second order. So these are the concepts we are going to cover today. If you look at the number of concepts, it's not very high, but let me tell you, individually, they are very important, and try and understand the pattern and essence of the algorithm that I'm going to teach you today. Okay, so let's get started. First of all, I'm going to talk to you about reducible to homogeneous equation. So as you can clearly see that there's a form going on. dy dx equals to a1x plus b1y plus c divided by a2x plus b2y plus c. The point is, if you think about a homogeneous differential equation, so obviously the numerator and the denominator, both of them should have been a homogeneous function of the same degree. So if I look at this portion, all right, this is homogeneous and it has degree 1. This is the portion where we have the same thing, but somewhere down the line, you see that there's a constant present here. And as a matter of fact, this constant will actually uh, be the basic problem between this one and homogeneity. So we are going to do some basic substitution so that it can be reduced to a homogeneous equation. And then from there, we can definitely apply what we have applied earlier for homogeneous equation. So what is the substitution here? I'm going to put small x equals to capital X plus h and small y equals to y plus k. Now the point is, whenever you're thinking about these kind of substitutions, you can clearly see that h and k are constants that we are still supposed to determine. We don't know about the constants. So there's a condition on that constant. What is the condition? The condition is, in general, the constants are supposed to vanish. So for that, I need to have these two things. So I'm going to choose h and k in such a way that these things are going to happen. Now, let's see the basic algorithm here, how we can solve this, and also why we need the condition. Let's just do one sum so that you have a very clear idea of why we are substituting this and what are these conditions. Okay. So let me show you an example. After that, if you have any problems regarding this, you can let me know, because these are some conditions that we are going to use. So you need to be absolutely sure about the reason behind this particular substitution. So let's get started with one simple example. So the first thing that you do is you write it down in the required format so that you can see the condition, you can do the substitution and the rest. Okay. So the first thing you notice is the ratio. the ratio of the coefficients of x and y, they do not match. So in this kind of cases, what we normally do is we do this substitution. Now, as you can clearly see, we still don't know h and k. So how do I actually figure out h and k? They will basically satisfy this. Okay. So as you can clearly see, these are the condition it needs to satisfy. So that is why just put this as k and this is h plus 2, that should be 0. Similarly, this one. Okay. So if you solve them, this is what you're going to get. And once I put the value, this will be the new equation. Now, before we move on to solving this is very, very simple. So this is basically a homogeneous differential equation. So this is very simple. So let's talk about this portion first. Okay. So what do you check? You have the particular format here. You check whether the ratios are unequal or not. You put this substitution. All right. This is the third step. And after the third step, this h and k, they are yet to be determined. And how do I get that? I get that from this particular condition. Look at one thing. If I put x plus h here, just look at one thing, which is very, very simple. I'm putting h plus k here. I'm putting x plus h here. And here I'm putting y plus k. And c was already there. So if you look at this entire thing, what will be the constant? The constant will be A1H, B1K plus C. So this is the constant after you do the substitution. All right. Now, since I don't need the constant because I need a homogeneous differential equation, that is why we make this constant 0. We choose h and k in such a way that this constant will vanish. And similarly here also, if you put x plus h and y plus k, you will see that the constant part will be this. Okay. And we choose it in such a way that this will vanish. So once we do that, you will actually have a differential equation which is homogeneous. Now look at the name, then it will be very clear why we have the substitution, so that it's reducible to homogeneous equation. Now what you have is a very simple homogeneous equation. Let me just show you the previous part here. Y plus x by y minus x. Okay, so here you have y plus x divided by y minus x. Now, if I give you this particular, function for both the cases, you can clearly see that individually they are homogeneous. They have the degree 1. So it's very, very easy to deal with. So what do? We put the substitution y equals to vx. And then we already know how we normally deal with homogeneous equations. So, sorry, let me remove the ink so that you can see better. So you put all the values and then you separate the variables. Fair enough. If you guys have any problems with any steps, you can let me know. But just let me tell you something. You have already done homogeneous equations in the previous class. So I'm hoping that you people are comfortable with this algebraic adjustments that we are doing, or we have already done integration. So let's focus on the new part that we have learned. The rest portion, the rest of the things that we are going to do in the sum will be actually a good exercise for the concepts that you have already covered. So then you substitute for homogeneous equations, you separate the variables. Individually, you are going to integrate, and this is what you're going to get after integration. So basically, if you look at this one, you can clearly see that if this is z, what will be the differentiation of this? 2 into v minus 1. So I need a half here. So this will be half into ln of this entire denominator. Fair enough. This is minus ln x, and since all the terms are in logarithm, I have taken the constant as a logarithm of something as well. Okay. So do some basic things about logarithm, that log a plus log b is log ab, etc. So this is what you're going to get. Okay. So remove the logarithm. This is what you're going to get. Now be very, very careful about one thing. If you look at this particular equation, it has small v, it has capital X, and all those things were introduced for our own benefit. So make sure you replace them to get the ultimate answer. Now I'm putting v equals to y by x. So what was y? Y was actually y plus k. Okay. So sorry. What have we put here? Y equals to y plus k. So capital Y will be y minus k. Here k was minus 3 by 2. So this will be y plus 3 by 2. All right. This is what I'm going to put here. And similarly, you can see that capital X will be X plus half. So I'm putting all the possible values here. I'm putting this capital X is this. I'm putting V equals to this one. And this is what you're going to get. Okay. I have compactified it here. I want you people to go ahead, and whenever you're studying at home, you're actually revising all these things, make sure you do the intermediate steps properly. If you get stuck anywhere, feel free to ask, but make sure you do these kind of manipulations on your own, because at the end of the day, you need to practice these things. Okay, so this was our first concept, reducible to homogeneous equation. I hope you understand the pattern where you can apply this, and then the algorithm. And there are some delicate things about the algorithm, the conditions, and all these things. I hope you understand why we have done this. Okay, so this was our first concept. If you guys have any problems regarding this, feel free to let me know. And if we are investing time in the first few slides, it's going to help you in the coming few slides, because obviously we'll do some examples on this. Okay, I hope this is okay with all of you. So let's move on to the next one. In the meantime, if you have any problems, you can definitely let me know. This is the second concept we are going to talk about. If you can see the form that we have taken here, they're very, very similar. But the only thing here is, unlike the previous case, in this portion, the ratios are the same, and suppose it's k. All right, so what we do for this thing is very, very simple. We basically put this as v. Okay, you can take this as v, or any one of the things like a1x plus b1y equals to v, anything that's convenient. So let me just show you one example so that it's absolutely clear. So whenever you think about a particular form, okay, so there's this solve this one into dy minus this into dx equals to 0. First of all, see the form of dy dx. See whether you have the particular form and the particular condition or not, okay? So dy dx will be this one. I have written this directly. So dy dx will be actually this divided by this, okay? Now I can take 3 common from this. So this will be actually 3 into x minus 2y plus 2 divided by x minus 2y plus 1. So 3 by 1, okay, if you compare the coefficient, is same as minus 6 by minus 2. So you have this structure, you have this condition. So what we do is, now that I have written it down in this particular manner, you know that if I substitute this will be purely a function of v. So see what we have substituted. I have substituted this as v. If you differentiate both the sides, you will get this 1 from x minus 2 into dy dx, right, equals to dv dx. Instead of that, I have just written y dash and v dash. So these are just differentiation. This is basically dy dx. All right. So if you guys have any problems up to this portion, let me know, because the rest of this one is pretty simple. Try and understand the structure and the condition that we require, and also the substitution that we have made here. Once we actually put all the values, this is what we are going to get. Okay, so this is y dash. What is the value of that? Y dash will be basically 1 minus v dash divided by 2. Fair enough? That will be y dash. So this is nothing but, look at this one. I'm going to put this as v. Okay, so this is 3v plus 2. This is v plus 1. All right, so this is what you're going to get. V dash is dv dx. If you are not comfortable with this particular notation, feel free to write dv dx, because ultimately that's what we are going to write. So this is what I get. Okay, take this to the side, whatever you have here, do the calculations properly. This is 1 minus v dash, so v dash will be 1 minus this. Okay, so do the calculations properly, and this is what you get. Fair enough. I hope this is okay up to this portion. So let's move on to the next slide. But if you still have any other queries regarding the things that we have done in this particular slide, you can definitely let me know. So now we separate the variables. So if you remember, this was actually v dash. V dash was equals to this 5v plus 3 by this one along with the negative sign. So dv dx is this. We separate the variables. All right. Before we move on, because this integration is not very difficult, you know how to deal with, linear things. I'm going to show you the calculation right away. So let's not talk about that for a moment, because I'm sure you people are, you people actually can solve these things, because the integration is pretty simple. You are intelligent enough to solve these things, or at least see how we can go through this. Just let's talk about 2-3 things. So if you look at the first thing that we talked about, it was reducible to homogeneous equations. And this one is non-homogeneous equations. Look at the format. They're pretty simple, but just with one condition, that the ratio is either same or they're not same. So these two things, these two conditions will actually give you two different things. In one case, we are reducing it to a homogeneous equation. In this one, actually, we have reduced it to a variable separable form. So this is very important. Though the structures are looking very, very similar, make sure we understand how they are different from each other and what we are actually trying to do. The basic intention behind substitution is you reduce it to something that you already know. So even if you think about homogeneous differential equation, at the end of the day, you do some substitution like y equals to vx, and you come back to variable separation. Okay, so that's what we normally do for all the cases, but maybe the journey that you have to take for that ultimate step of separation of variables and then integrating, that can be different. So understand the pattern, the structure, the algorithm, so that you get to that final step. Fair enough. So that was the theory part for these two concepts. I'm going to move on and see some mixed examples. Okay, so I hope this is okay, but if you still have any doubts, feel free to let me know. Let's see some examples so that these things are absolutely clear to you. All right, so this is the first one. So the first thing that you notice is clearly you have the pattern going on of a1x plus b1y plus c, and there's the same thing in the denominator, etc. So you see the pattern very clearly. The first thing that comes to your mind is, let's just check the ratio. You can clearly see that 1 by 2 and 2 by 1, they're not the same. So what we are going to do is do some substitution and reduce it to homogeneous differential equation. Now, what is the substitution that you need to do? X will be x plus h and y will be y plus k. Sorry, y will be y plus k. Okay, so this is very important that you understand this. H and k are still to be determined. Okay, so look at what I have written here. Dy dx is this. I have just put the values. You see, I have just put the values. It's very, very simple. I can write this as this one. This is x plus 2y. So what is the constant part? The constant part is h plus 2k minus 5. And here the constant is, this is 2x plus y. It's okay. The constant is minus 2h plus k minus 4. All right. Sorry, this will be plus. So the intention behind this particular substitution is you need to actually vanish the variable. So for that, I'm going to do these two things. Okay, first of all, this constant should be 0, this should also be 0. So choose h and k in such a way that these two things are going to be 0. So solving that, I'm going to get h equals to 1 and k equals to 2, and this will reduce dy dx to this one. Now this is a homogeneous differential equation. So after that, we know how to treat homogeneous differential equations. So make sure you understand each and every step of this particular slide, because this is a new thing that you have learned. Okay, so just check the calculations and see whether you understand it or not. Understand the basic algorithm here, as well as the calculations and logic why we are applying this substitution, and what is the condition all of a sudden, why do I need the condition, etc. So make sure you check that, and let me know in case you have any trouble. Okay, so now that I have got a homogeneous differential equation, I already know how to solve it. So let's just go ahead and solve that. So what is the substitution that we use? It's a very classic substitution, y equals to vx. So we change the things accordingly, and this is what you're going to get. Okay, put the values. So v plus x dv dx will be whatever value you get from this x plus 2y divided by x 2x plus y, etc. So put the values, and this is what you're going to get. Fair enough? I hope this is okay with all of you. So the next thing you do is separation of variables. A calculation ta kore nibi. Okay, do this calculation. This will actually give you 1 minus v squared divided by 2 plus v. I'm taking it into this side, and this side is actually dx by x. Okay, see the calculations properly. Sometimes I have skipped a couple of steps, the basic algebraic manipulations and calculations, but make sure you understand them. And nijera kintu ei calculation gulo korbi. You need to practice more and more, because here in this class I can take 2-3 examples and show you the reason behind the substitution or the entire process, but you really need to practice. So ultimately we have variable separable form, and we have integrated, and this is what I'm getting here. Okay, so what you're going to do is you can factorize this as 1 minus v and 1 plus v. So what do we have here? We have the denominator as product of two linear expression, and there is a simple linear expression in the numerator. So you already know how partial fraction works. So this is what you're going to get. All right, partial fraction আমরা already জানি কিভাবে. I know that this is complicated, but if you think about each and every step, okay, the intermediate steps, they are not very complicated. Just look at it, piecewise. Okay, the first part is substitution that you have just learned, and then some calculation. Then you have the homogeneous differential equation. Then you put the basic substitution for homogeneous differential equation. Then you have the integration. And so treat this as a separate sum of integration so that you can actually practice that as well. And this is what you're going to get. So bhalo kore calculation gulo tora check kore nibi. If you get stuck anywhere, always come back and we can discuss that. Okay, so this is what we are going to get. See, I have taken this half to the side, and that's why it is ln x square, and this is 2c, and here we have used log a minus log b as log of a by b. Since we have 3 here, I've taken this power. All right, so some basic calculation, and this is what you get. Okay, do the calculations properly. Here I can take ln x square to this side, so this will be actually here in the denominator. You put the value of v as y by x. All right, so this is what you're going to get. Make sure you understand each and every step, because this capital X, capital Y, small v, all these things are for some sort of manipulations, so that we can reduce it down to variable separable form. So make sure you substitute them properly. And then this part is very crucial. I'm going to put the value of x and y. How do I do that? Very simple. What was the substitution? The substitution was x equals to capital X plus 1. Okay. And y equals to capital Y plus 2. All right. So if I just add them, x plus y, okay, that will be small x plus small y minus 3. So that's what I have put here. Similarly, x minus y will be this. Put the values properly, and this is what you're going to get. If you guys have any trouble regarding this, feel free to let me know. Otherwise, we can definitely move on. Okay, do the calculations properly. Calculations গুলো একটু ঠিক করে করবি কারণ I know that it can be a little difficult because you have so many things going on, and each and every part of the sum is a separate sum itself from that particular chapter or that particular concept, so it can be a little difficult, but make sure you understand each and everything properly. Okay, so let's move on to the next sum. As you have, I hope you have already understood the structure and the difference between this sum and the previous sum. Here the ratio is the same, so the treatment is fairly simple. This is 2x plus 3y, this is 4x plus 6y. So I can write it as actually 2 into 2x plus 3y. So what is that common thing? The common thing is this. Okay, so if you remember this reducible to variable separable form, there also we were talking about a particular type, ax plus by plus c. If you get this particular type somewhere, then definitely you can substitute, and this will be just one variable so that you can separate them. So this is the substitution, very simple. Once you do the substitution, I have this particular part, which is very simple, u minus 1 divided by 2u minus 5. Here you have to replace dy dx as well. So that is why we have differentiated both the sides. This is du dx equals to 2 plus 3 into dy dx. So I have all the required values here. So what is dy dx? Dy dx is actually du dx minus 2 divided by 3. Fair enough. That's what I have written here. And look at this one. This is u. So this is u minus 1. This is 2 into u. So this is 2u minus 5. So that's it from the first portion that we have. Shomojyoti, 1 minute dara. Aage last year answer. Just 1 minute. I'll just go back to the previous slide. Just 1 minute. Answer ta dekhe ne, kono problem thakle bol, and if you have understood this, then let me know. I'll move on to the next slide. Okay. I actually want to take back-to-back questions in the similar format so that you understand the difference between the case where the ratio is the same and the case where it's not. So you know which kind of procedure we are going to use there. All right. So eta holo. Now I'm going to do some basic calculations here. Take 3 to the side, then add 2. So this is du dx. Okay. Very simple. Get the value of du dx, and then once you get the value, you take this 2u minus 5 to the side, this to the denominator, and dx to this numerator. Fair enough. So what do we have here? The variable separable form. So let's integrate both the sides. Again, very, very simple. So this is what you're going to get after integration. Make sure you adjust these things correctly. What I have done here is very, very simple. Just one thing, let me show you something. If I take this as 2 by 7, okay, the numerator, I'm writing the numerator. I can write it as 7u minus 13. Okay, now you have a constant here. So adjust the constant here as well. So this part will give you simply 1, which is on integration giving you u, and here you have some logarithm going on along with the constant. So make sure you break it up properly. Now this is a very good practice for integration as well. আমি তোদেরকে বারবার করে বলছি যখনই কোনো জায়গাতে, be it the definite integration where you have to find out out the integration and then put the values, or be the area under the curves where you have to find out what kind of integration you're going to use, what is the limits, and again তোকে integrate করতে হবে. Differential equation ও সমস্ত জায়গাতে, everywhere you see at the end of the day you are integrating, because once you form the differential equation you basically differentiated the original relation. And now that you want to get back to the original relation and find out the relation between x and y, not taking this dy dx d2y dx2 etc into account, then you have to integrate. So shomosto jaygaয় কিন্তু integration ta lagbe. So whatever you have learned in integration, make sure you repeat that, because these concepts are heavily dependent on that. So what do we do next? We put the values and that's it. All right, so put the value of u, which is 2x plus 3y, and these things will be sorted. Okay, so I hope this is all right with all of you. Just check whether you have any doubts or not. Let me know in case I can help you out with any other things here. So that's it from this one. Let's move on. তাও যদি কোনো problem থাকে, so I have put some basic done some basic calculations here. I've taken the 7x to the side, etc. And this is a new constant that I have put here. The rest is pretty simple. Okay, so এই calculation গুলো তোরা নিজেদের মতো করতে পারবি. Make sure you practice that a lot, but as an addition to what you're going to do here, what you have already learned about variable separation and integration, etc., make sure you understand this part. This part is the new portion that we are talking about, so make sure you understand that. All right, so this is the third topic, and let me tell you that this is one of the most important things that we are going to cover here. So this is something you really need to understand properly. Most of the questions that I've seen in JEE Main for the last couple of years, they come from this linear differential of first order. So 40-50% of the questions I've seen coming from this particular portion. So make sure you have a good grip on this particular concept. So before we move on to see how we can solve linear differential equation of first order, let's see the format of linear differential equation of first order. Okay, so let's look at all the terms here that we have used. First order, what do we mean by that? We know that the first order differential equation will have maximum dy dx. That's it. You cannot have higher order differential coefficient. Next, linear. What do we mean by linear? You know, for linear differential equation, you cannot have the power of y or any differential coefficient as more than 1. It has to be 1, and also they cannot be multiplied among themselves. Fair enough? So this is how it should look like. You have dy dx, you have y, and that's it. So this is like dy dx plus py equals to q. This is a linear differential equation of first order. Here p and q are functions of x or constants. Okay, so make sure you understand the structure properly, because whatever we are going to apply, you have to make sure that you have the particular equation in this format, and then you identify what p is or what q is, and then you can go for the algorithm that we are going to apply here. Let's take an example. Look at this. So you can clearly see that, okay, this is p. Here p is a constant, so it's okay, it's 2. And this is q. So you have this dy dx, you have this one, and also this is qx. Okay, so make sure you understand the format properly. This is another one, very simple, dy dx plus y into a function of x equals to another function of x. So you can have functions of x or constants, it's perfectly okay. But as you can clearly see the polynomial here, you have dy dx and the next order thing, which is the lower order thing, y, and you have some coefficients or constants going on. This one is very, very crucial. Okay, though it's not looking like the standard differential equation here, but as you can clearly see, the dynamics has actually been reversed here. Initially, we were treating y as the dependent variable and x as the independent variable. But in this case, as you can see, we are talking about dx dy. We are taking x as the dependent variable and y as the independent variable. So that is the dynamics that we are, having here. So obviously, if you compare this part, it should have dx dy. Just try and understand this. I'll talk about this actually. So plus, look at this. This is what you had, right? So here I'll have something into x. Okay. So I'll have something into x equals to y square, etc. Some function of y. Let's just take this as x for the time being. Okay. So these are the formats that you need to understand. So suppose this is y into x, etc. Okay. The next thing that you need to learn is how we can solve these kind of differential equations. Now, before we go on to the algorithm, let me tell you just some simple thing. Think about the product rule. আমি যদি একটা product rule use করি, this p is actually, it's a function of x. Okay, it can be a constant, but in general, I can just write it as a function of x. Even if it's a constant, it's perfectly okay. All right. So suppose I have y into fx. Just think about this one. Suppose you have this, particular function originally. What happens if you differentiate it? You will have dy dx into fx. Fair enough? And you will have y into f dash x. You understand what I'm talking about? So if you differentiate this, this is what you're going to have. Now, once I'm going to actually solve this one, I'm going to integrate this and find out some sort of, function which on differentiation gave you this, because that is the basic rule here. So look at this format. It's pretty similar. I have this dy dx here. I have this y here. So what we are going to do is we are going to find out, this is very, very crucial, an integrating factor so that this particular part can be put in this form. What do we mean by that? Let's see. So for these kind of equations, what we do is we find out the integrating factor. The integrating factor is given by this. All right. So look at this. This is e to the power integration p dx. Okay. So this is the integrating factor. We multiply this equation on both the sides by this integrating factor. And then this will be the solution. The solution will be y into integrating factor equals to, since I have multiplied this part with the integrating factor as well, now I will integrate, and this is what we are going to have. All right. So two things. Let's notice two things. First of all, why we have this all of a sudden. The beauty of this integrating factor is such that once you actually multiply both the sides by it, this particular part will be the differentiation of y into if. So I just show you the product rule here. If you actually differentiated this, this is what you're going to get. So once you integrate, this is the ultimate thing. And here you can definitely integrate this and it won't be any, problem. Now, this is very crucial. Let's look at all the points here. I know I'm discussing about the theory, and sometimes it just sounds a little vague and you don't understand the exact thing. So I'm going to do some applications and then talk to you about the algorithm and the essence of the algorithm as well. Then jodi kono problem hoy tale abar solve kore debo. Thik ache? Now this part is very, very crucial that you understand that sometimes we need this form. দেখে এটাকে differential equation of first order মনে হচ্ছে না, linear differential equation, but see what we have done here. we have used dx dy. So this is very, very important. Keep an open mind. If you remember what we were, talking about while we were discussing the concept of area, normally we use y dx. Fair enough, we have done that. We have integrated y dx to get the area under the curve, the simple curve. But sometimes keep an open mind and use the formula, the alternate formula that we have, which is x dy. Okay, sometimes when you have some sort of problem going on and you know in terms of complications regarding the sum, make sure you use the alternative thing as well. So keep an open mind, because sometimes in your examinations, this is one of the forms that we normally see. Now that we have talked a lot about the theory part, it's only fair that we go and see some sums and understand the algorithm, the pattern, and also the idea behind this algorithm. Let's look at this one. আমি প্রত্যেকটা step বলছি how you're going to go through this algorithm, and then you'd see whether you can actually relate to each and every step or not. First of all, before we apply this rule, what we have learned here, let's see whether we have the particular structure or not. So this is dy dx plus py equals to q. Compare, and this is what you're going to get. So p is actually 2 and q is 6 into e to the power x. Okay, so this is the first step where you see the structure, and this is the second step. Actually, this is kind of the first step as well, because you identify the functions you have here of p and q. Second step is this. Third step is very, very crucial. It is very crucial. This is third step. Integrating factor. Integrating factor will be, how do you find this out? So look at this algorithm here. E to the power p dx. So what was p? P was actually 2. So this is 2 dx. So I can take this 2 outside. All right. So this is what you're going to get. Fair enough. Okay. So this is e to the power 2x. So this is the third step. So maybe let's talk about this as the first step, because you still need to understand the structure. This is the second step. What is the third step? The third step is you actually multiply the integrating factor on both the sides. Okay, and then you integrate. The beauty of the integrating factor is such that once you multiply this on integration, this will give you y into if. This is the beauty of this particular integrating factor. And here that you have multiplied this, so this will be q into this if. So we are integrating this part, and of course you'll have a c here. So what is the solution? The solution will be y into e to the power 2x. So y into integrating factor equals to integration q. This was q, originally what we had in the LHS, and this is e to the power 2x. All right. So this is very, very crucial. So q into if equals to c. Okay. The rest is fairly simple, because if you look at the right hand side, it's very, very easy to integrate. This is actually e to the power 3x. So that will give you e to the power 3x by 3. So this is going to be, if you look at this one, this is 6 into e to the power 3x. So on integration, it's going to give you 2 into e to the power 3x. Okay. So I have actually taken this e to the power 2x to this side and do some basic calculation, and this is what you're going to get. Now, let's talk about this particular part. Why all of a sudden I wrote it directly? So this is the integrating factor, right? The idea is to multiply this on both the sides. Fair enough, this is what I'm doing. I'm actually multiplying e to the power 2x, both the sides. Fair enough. So this is what I'm getting here. So this is 6 into e to the power 3x. Very simple multiplication. Can I do that? Now the beauty of the integrating factor is such that this is nothing but d dx of y into e to the power 2x. We choose integrating factor, the formula of this e to the power integration p dx. The formula is chosen in such a way that this will actually give you y into the integrating factor on integration. If you look at the product form, look at the product form here. Once you differentiate this, what do you have? You keep this e to the power 2x constant, you have dy dx, plus you keep this y constant. For e to the power 2x, you have 2 into e to the power 2x. So that is the beauty of this integrating factor. What we normally do is once you multiply this on integration, this will give you y into if. And here what you have is q as well as the integrating factor. So I hope the algorithm is okay with all of you. If you understand this part properly, we can save time in the coming few slides. That's perfectly okay. So make sure you understand each and every step, and also all of a sudden why we are writing this, solution is given by this. All right, so understand everything. And if you look at the integration here, the integration is fairly simple. Again, we are talking about solution of differential equation, so we will have to integrate. So make sure you practice integration properly. Chalo, পরের অঙ্কটা দেখছি. All right. Now, this is very, very crucial. Look at this one. Before you find out what is P or what is Q, make sure you have the form. So if you look at the original form, you do not have anything multiplied with dy dx. Okay, the form was this. Dy dx was alone. So what you're going to do is, in case you see any factor multiplied with dy dx, make sure you divide the entire equation by this factor, and then only talk about px and qx, because look at this form here, you don't have any coefficient of dy dx. All right, so make sure you get rid of that. And now this is the form that I'm talking about. Fair enough. So as you can clearly see that this is the form. So the first step is to write it down in the form, and also this is P and this is Q. So what is P? P is this and Q is this. All right. So this was the first step. Do some basic manipulation, have the form properly, and also find out P and Q. Next step is finding out the integrating factor. The integrating factor is again very simple. E to the power integration P dx. Okay, now this integration is very, very simple. E to the power tan inverse x. So we have the second step. So this was the first step, finding out the structure as well as P and Q. This is the second step. Third step is the solution. The solution is given in such a way that this is y into if. So we are sorted with the LHS, right? Because we have already found out the integrating factor. So the solution will be y into if. Okay, so we are sorted with the left hand side. Now let's look at the right hand side, which is our fourth step. The right hand side is, this is the qx. We already had this qx. I have actually multiplied this with the integrating factor. Fair enough. Now what is your job at hand? You're supposed to find out this integration. I have written it directly, but let's just see what we can do here. This is e to the power tan inverse x whole square, right? So this is e to the power 2 tan inverse x. Fair enough, because you have this e to the power tan inverse x into e to the power tan inverse x. So this is e to the power 2 tan inverse x divided by 1 plus x square. I have written it directly, but let's just see what we can do. If I put tan inverse x equals to z, then 1 by 1 plus x square is actually its derivative. So this is of the form e to the power 2z. All right. So e to the power 2z will give you e to the power 2z divided by 2, and that is why we have this particular form. I have written it directly, but make sure you understand the step here. All right, if you guys have any problems regarding this, feel free to let me know. I'll help you out with this particular integration or whatever is going on here, but make sure you understand these things properly. Okay, so what we have seen here as an added thing for this chapter is not very difficult, because you just need to find out P and Q and find out the integrating factor, and then for the solution you have this LHS sorted, but for RHS again you have to integrate. So this particular algorithm is heavily dependent on integration. So go ahead and practice. So that's it. So some basic manipulation, and this is how it looks like. Okay, let's do another sum. So if you guys could not see this last line, so this is what we have done. So some basic adjustment I've taken to the side, etc. So this is actually 2c, but you can write that as c prime or whatever. This is perfectly okay. All right, arekta sum kori. As you can clearly see here, the pattern is very obvious. Dy dx plus px into y equals to qx. So for that pattern, we are supposed to find out p and q. Okay, so p and q, and then the structure. So that was our first step, which is very simple. The second step is to find out this integrating factor. So this is the integrating factor. Look at this one, e to the power integration sec x dx. Okay, because this is p, so I'm going to do this e to the power integration px dx. So sec x on integration will give you ln of mod sec x plus tan x. So these two things are, the inverse things. So this will simply give you sec x plus tan x. I'm not considering this mod. You can continue with that, but once you talk about this function to be defined, so there are some things that we automatically assume, so it's perfectly okay. So now that you have found out the integrating factor, what happens is the third step. For the third step, again, as you can see, the LHS is absolutely sorted. I don't have any problem with this. It's okay. And for the RHS, I need to do some basic trigonometric integration. So what do we have here? We have tan x into sec x. Okay, so sec x tan x is very simple, because this will give you sec x on integration. Now here you have tan square x. Just multiplying this. Look at this. This is very simple integration, but obviously a good practice for what you have learned. Now here we don't need anything. It's just from the antiderivative method. Now tan square x I don't know, but I know that tan square x can be written as sec square x minus 1. So I know that this will give me sec x on integration, this will give me tan x, and also minus 1 will give me minus x. So the integration is fairly simple here, but of course a good practice. So this is what you're going to get. All right. So I hope this is okay with all of you. If you still have any doubts, feel free to let me know, and we can always repeat or come back to the previous sums that we have done. ठीक है? It's a very simple thing, but very crucial. Try and understand each and every step properly. And also, this is something we write directly. Okay, we don't go through the trouble of integrating the left hand side, etc. But the beauty of the integrating factor is such that this is what you're going to get on integration. Okay, chalo, arekta sum korchi. All right. So all of a sudden, what you notice is this is not looking like something that we know. Yes, initially we had some, coefficient of dy dx, fair enough, but that was simply a function of x, so that we could divide and get the rest of the things sorted. But here, as you can clearly see, this is not a linear differential equation in dy dx normally that you do. Okay. let's just change certain things. Very simple. So, try and write it down in this particular form. This is very, very crucial. So sometimes for your examinations, what you see is, whenever you see that none of the forms are working, because if you take, dy dx to this side and the rest to the other side, it's not, variable separable, it's not homogeneous, or you're not getting any form which can be reducible to variable separable, or homogeneous or non-homogeneous. You don't have any form going on. So for those kind of cases, keep an open mind, because it can be very, very, it's very likely that probably there's some alternative, form of the standard thing that we normally don't consider, but you need to consider here. So some basic adjustment, and this is what you're going to get. Now, if you look at the form here, the form has a very, structural thing going on, which is similar to the previous one. You have dx dy, you have p into x and q. So initially it was like dy dx plus p into y equals to q. Fair enough. There p and q were functions of x. Here p and q are functions of y. As you can clearly see, the functions of y. So make sure you people keep an open mind, because for all the cases that we are going to do here, it's not necessary that for a differential equation you have this with dy dx. Okay, so if none of the things are actually happening for different types of structures, this is one structure that you need to check as well. So this is p and this is q. It's fairly simple. So you find out the integrating factor. Just try and relate to each and every step. Okay, so initially we had p dx, because p was basically a function of x. Here I'm doing p dy, because p is a function of y. So this is integration p dy. It's very simple. It's just logarithm of y. So this is y square, and that's it. Very simple. Okay. So understand each and every step properly. Solution. Now this is very important. What did we have in the previous case? We had y into integrating factor. Here we have x into integrating factor, and q into if, and we are integrating with respect to dy. This is very, very crucial. So just the dynamics, that is the thing that has changed, because the rest is absolutely simple and similar. Just x and y, that has changed. Okay, so make sure you actually write all the changes properly. This is what we are going to do. So q was actually 10y square. Okay, and this is the integrating factor. It's very easy, because it will give you 10y to the power 4, which on integration gives you 2y to the power 5. So, okay. So I hope you understand that you need to keep an open mind for the alternate format of linear differential equation of first order. Okay. So if you guys have any problems regarding this, feel free to let me know. Otherwise, I'm going to move on to the next sum. So some basic adjustments here. I have taken y square to the side. You can do that, or this is also very simple and elegant. So you don't need to change that. But sometimes for options, if you have multiple choice questions, you will have options of different formats. So make sure you do some, manipulations and see which one of the options are matching. Now, this part is absolutely crucial. Okay, this is something I've been saying for all the things here, but try and understand each and every concept and the weightage of that concept, how this is very, different from the previous one. What is the new thing we are learning, and how we can use the previous, knowledge to try and solve this. Look at this. Every time we have, talked about a particular method of solving a differential equation, if you are lucky enough, you get the, structure right away. But sometimes kopal pora thakle, you'll have to do a couple of more steps to reduce it down to something we know. We talked about variable separation, then reducible to variable separation. We talked about homogeneous function, then reducible to homogeneous function. Now that we are, absolutely sure about how we deal with linear differential equations of first order, here I'm going to talk to you about some differential equations which can be, with suitable substitution, reduced to linear forms. So let's get started. The first thing that comes to your mind is when you're going to basically use this particular thing. Okay, so I had some sort of things going on, like, see, this is the structure. এরকম দেখতে হবে dy dx plus px into y plus q equals to qx, etc. So this is what you're going to get for a linear form, and that's something you're going to do. So the first thing, that the structure that you need to keep in your mind is this. All of a sudden you notice one thing that is causing trouble. This is the only thing that is different from the previous one. The rest of the things are absolutely similar. Okay, so what do we do here? We do a very simple thing. These kind of equations are called Bernoulli's equation, and there's a classic trick that we do which will help, which will actually reduce it down to linear form. And once we have the linear form, you know how to treat the linear form. So see what we are doing here. We are going to divide both the sides of the equation by yn. So I'm going to get rid of this yn, and as I need to have this qx here alone, which was the original thing, right? Originally you had this qx here. Here all of a sudden you have this y to the power n. So what we are going to do is we are going to divide all the sides, both the sides, by y to the power n. Then now this is the classic substitution. I'm going to substitute v equals to y to the power 1 minus n, or 1 by y to the power n minus 1. Okay, so if I just divide this by y to the power n, this is 1 by y to the power n, and this y is gone, y to the power n minus 1. All right, you understand these two steps? Third step is basically you differentiate the second step with respect to y. So obviously I need to put all the values here. All right, so this is actually v equals to this, so I need to find out the value of dv dx so that we can find out dy dx, etc. But before we move on to see all the things, this will actually reduce it to the linear differential equation which you need to solve. So these two steps are pretty technical. You don't have to concentrate on this. Make sure you understand the structure and this particular part, and then the substitution. All right, just one thing I want you people to notice, which is the beauty of this substitution. See what we have done after this. Once I have actually divided it, look at this one. 1 by y to the power n. This is y to the power minus n, right? This is y to the power minus n plus 1. So somewhere down the line, you know that they are actually just differing by 1 in the exponent. So if you differentiate this, this is what you're going to get. Okay, along with some constants, etc. That's okay, perfectly okay. But on differentiation, the exponent will get reduced by 1. So somewhere down the line, you're going to get this. So you understand this format properly. All right. Is there any problem with the substitution or how you get this? Because this essence of the substitution is very, very important, because sometimes you don't have exactly the Bernoulli's equation, but you have some sort of side. You will see this differentiation and substitution going on. So let me just show you one sum so that you have a clear idea of the algorithm. First ki bolechi, look at the structure. The structure is very simple. Dy dx we have y into something, which is like here we have -1, which is actually acting as px. Normally you have qx, right? Normally what you have is qx for a normal linear differential equation of first order. Unfortunately, there's this extra y square, which is causing some problem with linearity. Okay, so the first step is fairly simple. Find out the problematic y to the power n and divide both the sides. So this is what you do. Now just let's look at one simple thing, just so elegant. If I take this as some substitution, I'm going to get this on differentiation. That is the beauty of Bernoulli's equation. Okay, so the next part is very simple. I'm going to put v equals to 1 by y. If you remember, this 1 by y to the power n minus 1, that was the thing, or y to the power 1 minus n, that was my substitution. So I'm substituting this as v. Okay. Now, what is the beauty of the substitution? What will be dv dx? dv dx will be minus 1 by y squared dy dx. You see this part? This is the essence of the substitution. Just because I'm asking you to do the substitution and you blindly do this and then you have a linear differential equation, again blindly solve that, what is integrating factor and all. Just try and understand the basic, importance of this particular adjustment, so that if you have that essence sorted, you can use it for different other things as well. All right. The best part is this is actually minus dv dx. This is minus v. So I have taken the minus to the other side. All right. Now this part is looking much better. This is actually a linear differential equation. This is actually a linear differential equation. Why? Look, dv dx, just like dy dx, you have dv dx, you have something into v. This is 1. You can have different variables, etc. So here you have a function of x. So you understand the format. Suppose I'm just writing this dv dx plus what do we have here? We have px into v. Try and understand the format. If you guys have any problems with any steps, please let me know. Don't hesitate. It's perfectly okay. So the beauty of the substitution and then this adjustment and the substitution is that this is reducible to linear differential equation of first order. So you see this pattern, this is perfectly okay. Now I need the integrating factor. What is the integrating factor? It is e to the power integration p dx. Okay, the p is 1, so this is dx. So what is this? This is simply e to the power x. Okay. So this is the integrating factor. Fair enough? Look at each and every step carefully. So what will be the solution of this? The solution will be v, because v is acting like y here, into integrating factor. So the left hand side is sorted. For the right hand side, you need to have the integration of this function, of course, along with the integrating factor. All right. So what do we have here? We need to integrate this. If you remember, again, it's a good practice for integration. Look, if this is e to the power x, this is of the form fx plus f dash x. So how beautifully these things are used here, and you will actually practice different types of things. Amra onek jagate substitution korlam, integration korte giye partial fraction korlam. Here we are using a very simple thing about integration by parts. Most of the times ekhane kintu onek shomoyte integration by parts korte hoy, but this is the direct formula that we use. On integration, this is going to give you e to the power x fx. So integrate this. This is you are going to have very simple. What else? I have to put the value of v back. So let's put v equals to 1 by y So some basic adjustment, and this is what you're going to get. Okay, not showing the adjustment here. So just put the value of v as 1 by y, and after a couple of steps you're going to land onto this one. So I know it was complicated, but try and identify each and every step properly and understand the essence behind the step. So I know you'll be sorted. ঠিক আছে? কোনো যদি problem হয়, if you want me to repeat anything, feel free to let me know. I'll do a couple of more sums so that you have a very clear idea of what's going on. So let's move on. তাও যদি previous problem এ কোনো মানে কিছু problem থাকে which I can discuss, you can definitely let me know. Again, this is Bernoulli's equation. Let me just write it down properly so that you can see what is wrong with this. dy dx. Okay, fair enough. I know that this is going to be there. So I have this minus 1 by x into y. Up to this portion, it was okay. Then on the right hand side, I have a function of x square. Very good. So up to this portion, I did not have any problem with the original format of linear differential equations of first order. The point is this. So all of a sudden, you see in the RHS y to the power n. So obviously, this is something that I don't expect in the original linear differential equation of first order. So let's divide the entire thing by y square. So this is what you're going to get. Again, do you see the format here? 1 by y, 1 by y square. So that is the beauty of this substitution. If you understand the substitution, you'll see that it's even when you saw the integrating factor, it's the substitution or this integrating factor, the multiply thing that we do. So it's so beautiful that this will be absolutely compact, and this will actually give you some sort of linear differential equation of first order. So the substitution is again very, very similar to the previous one. I'm putting t equals to 1 by y. So dt dx will be minus 1 by y squared dy dx. Now I'm going to put all the values here. This is minus dt dx, this is minus t by x, and this part is 1 by x squared. Look at this. It is actually a linear differential equation of first order. Okay, so this is dt dx. You have a function of x into t equals to a function of x. So what is the format here? The format is very, very simple. What I'm going to, encourage you people to do is write down each and every step. So Rajiv sir, when he has talked to you about different types of strategies that you need to follow for examination, make your own notes. Ami ekhane ja ja bolchi. So write this, sum down in one part of the copy, and on the other part of the copy, like you just divide it into two part. One part you just write down the, vertically just write down the sum and just write down the algorithm or whatever steps we are doing here. On the right side, just write each and every step, the essence of each and every step, and look at the format, look at the structure. So since you people are just starting out, try and write down the basic structure again and again so that you have a very clear idea of what's going on. You see the structure, write down the structure, because this will actually help you to identify which kind of equation this is. So can I see this as a linear differential equation of first order? Yes. So now, what is the integrating factor? You know that the integrating factor will be e to the power p dx. What is p here? P is 1 by x. Try and identify each and everything. এই জিনিসগুলো পাশে লিখে রাখ. This will help you to, actually make a good note of everything that we are doing here, because at the end of the day, before your exam, you're not going to read 10 different reading materials and stuff. So you need something compact, but there's everything that you need. So make that note and write down the essence of each and every step and also the structure. Okay, so eta chole elo ki, this will be actually e to the power ln x, because 1 by x will give you ln x. So this is x. All right, so I have the integrating factor. So what will be the solution? The solution will be t into integrating factor equals to, look at this, qx. What is qx? Qx was minus 1 by x square along with this integrating factor dx plus c. Now this is very simple integration. Integration korle ekhane ki ashbe? This will just be minus ln x plus c. Of course, make sure you put the value of t because we assume t equals to 1 by y for our own convenience. So put back the value of t and that's it. We are sorted. ठीक है? So I hope this is okay with all of you. And so this is the algorithm behind the Bernoulli's equation, and make sure you understand the structure. You find out what is the y to the power n that's bothering you, divide both the sides, and whatever you have here along with this, y to the power 1 minus n, etc., so that you have the backup of the differentiation here. That's the beauty of the substitution. So let's do one more sum. All right. Now, if you remember this, the problem is initially you had this dy dx going on. I can divide it by x cube and this is what it's going to look like. Some basic adjustments I have done here. As you can clearly see, the point is every time you look at this, it's not very similar to what you have done previously. Here, along with e to the power x, you have something of the form y to the power n, and you're like, okay, I'm sorted, I'm going to divide it by this y to the power n, etc., and then put a particular substitution, and it will just come down to a linear differential equation of first order. But what I'm going to do here is actually try and use the essence of the substitution and how we use the substitution to reduce it down to something linear and of first order, and see what we can substitute here. Okay, I've done a very simple adjustment. Look at this adjustment, what I have done here. So this is actually 1 by cos y. So you can take this cos y to this particular side, and this is tan y is again, sin y by cos y. And I have taken this x cube, I've divided this entire thing by x cube. So this is what I have done here. Fair enough? Now, how does it help me? All right. So how do I see that? Okay, this is very helpful. I don't know what's going on. What was our idea behind the substitution? The idea was this part will entirely have x. No problem. Here I will have dy dx. No problem. Here I can have a function of x. Perfectly okay. Whatever is remaining, if you put this as something, notice that this is the backup of the derivative. It's not a classic Bernoulli's equation. But once we sort this out in this particular format, you can clearly see that, okay, this is looking much better. And I can clearly see that why we substituted this. And here you have a very similar pattern. Though it's not a very, general example of Bernoulli's equation where you had this y to the power n extra and you did all these things, but the essence is there. So this is what they test for your complicated entrance examination. This is what they test. Previously we have talked about homogeneous differential equations where you could not see this y equals to vx thing directly, like the degree of the homogeneity, etc., but you saw the presence of this particular expression which tells you that somewhere down the line this is homogeneous, and let's put this. So each and everything was a function of y by x. So you know that this is what you're going to do. So these things are tested, like how deeply you know the concepts. Okay. So আমি কি করব এখানে sin y টাকে আমি t assume করে নেব, and the best part is, see, this is the backup. This is what I'm talking about. Look at this. So you clearly see the backup. I'm putting the values here. Now, as you can clearly understand that this is a format which is a linear differential equation, basic first order format. Dt dx, you have this px into t, okay, and you have qx here. Very, very elegant, and just one, substitution, the basic essence of this particular algorithm, and you're sorted. Next key korbo, I'm going to find out the integrating factor. So for integrating factor, I need px is 4 by x here. So let's put all the values. So integrating factor will be this. So this is actually e to the power 4 into ln x, so which is x to the power 4. All right. So integrating factor, we have got the integrating factor. So what will be the solution? The solution will be t into the integrating factor equals to, this was q. Okay, look at this. This was q. This is the integrating factor. So this is what you have. So this is the integration you need to do. This is what you're going to get on integration, because this is going to give you x into e to the power x. Now this is very, very easy to integrate. You're just going to use the integration by parts, and basically on integration, this is going to give you x e to the power x minus e to the power x. Very, very simple. And also, as you can clearly see, I have put the value of t. Okay, I know this was complicated, but if you guys have any problems regarding this, feel free to let me know. And just let me tell you one more thing, which is absolutely important. Sometimes what happens is, class আমি যখন কোনো কিছু পড়াচ্ছি, I'm trying to, tell you the algorithm or the reason behind the algorithm. Try and make some notes of that, okay? Because once you understand this in class, it's perfectly okay. Sometimes you go home and when you revise, you don't remember what was the logic, you don't remember a particular step. So write down the things properly, and when you revise, if you get stuck with anything, like you don't remember, you understood that in the class, which is perfectly okay, but then when you actually try to revise it, you just got stuck. So always come back with those kind of queries and clarify them. ঠিক আছে? All right. আরেকটা অঙ্ক করব. Okay. So this is the format I have written here. So it's very, very simple and elegant. Multiply this. So you have this e to the power minus y. I'm taking e to the power minus y to the side. So this is e to the power y dy dx. So this will be e to the power 2x minus e to the power x into e to the power y. So some simple adjustment, and this is what you have. So try and see the adjustment here. Do the calculations properly and see this is the format that you should have. If you have any problems with the format, you can let me know, and anything that you want me to repeat. Now the best part is you have dy dx. Okay, this is something I'm going to have in the original format. This is something I'm going to have. This is also okay. So what are the trouble causing these two? Best part is substitute this as t. This is the backup of differentiation. Okay, not a absolute general form of Bernoulli's equation, but if you understand the essence, you know what to substitute. E to the power y equals to v, so e to the power y dy dx will be dv dx, and see, this is linear in v. Very simple linear equation. So you understand how it's reducible to linear equations. Once we are sorted with that, dv dx px into v equals to qx. All right, so this is the thing, very, very simple. What do I need? Integrating factor. All right, integrating factor will be e to the power integration p dx. Okay, so this is e to the power x. It's looking very bad, but it's okay. We'll do some adjustments and see how we can deal with this. As you know, once you talk about the solution, this is small v, sorry. As you talk about the solution, you know that these things are absolutely simple, okay, because the left hand side is absolutely sorted. you have this v into integrating factor. So I don't have to worry about this. So let's look at this one. So as you know that this is looking a little complicated, but the best part is e to the power x will give e to the power x on differentiation. So let's just do some substitution. I'm putting e to the power x equals to z. Okay. So here I can write it as e to the power z. I hope you understand this. This part is e to the power z. Look at this part. I can write it as e to the power x into e to the power x dx. All right. Now this part is actually dz. Okay. And this part is z. So it's a very simple substitution. And this is what you have. So what do we have here? This is something we already know. একটু আগেও এই same integration করেছি শুধু x দিয়ে বোধহয়. So this is what you're going to get. So it's very, very simple, which is actually z minus 1 into e to the power z. Make sure you understand the integration properly, because as I have told you repeatedly, whatever form you are using doesn't matter. At the end of the day, you're going to integrate these things. So make sure you remember all the basic things about integration. So let's put all the values here. Let me erase the ink so that you can see better. So I'm going to put all the values, and this is what you're going to ultimately get. Okay, check kore ঠিক করে বুঝতে পারছিস কিনা. If you guys have any problems, let me know. I know these things are a little not little complicated, they're very complicated. So yeah, that's it. Okay, all right. So let's see what we can do here in the other things, because just 1 minute. Okay, all right. So this is the last sum we have on a reducible to linear differential equation of first order form. So if you guys have any problems up to this portion, you can let me know, because it's very crucial that you understand these things properly. Okay, so they কিন্তু যখনই ভালো কোনো এক্সামিনেশন দিবি, যেগুলো খুব মানে ডিফিকাল্ট যেগুলো এক্সামিনেশন তোরা দিবি, যেখানে ওরা টেস্ট করে how deep your knowledge is, because you know how to treat Bernoulli's equation, but do you understand why we do the substitution? There's a substitution and there's this backup of the differentiation, which is the essence of the substitution. So if you understand that, these things will be absolutely sorted, and you will understand that, okay, this is why we substituted this. So even if you have a different type of thing where the essence of substitution is there, you can definitely do this. Okay, so that's it. So these were the 4 concepts that we dealt with. Next, I'm moving on to something which is very, very important but difficult. So let's not be like, okay, na bishon soja ekkuni bujhe jabi. It's not like that. This is a little difficult. These are called exact differentials. Okay, so before you guys have a heart attack, let me just tell you the essence of this thing. So forget about what is written here and what we are going to do in general for exact differentials. If you remember that there was the first part that we considered for linear differential equations. Why did we multiply by the integrating factor? What was the idea behind introducing the integrating factor? That was to make the equation, the right hand side and left hand side. The left hand side was on that in a very complicated manner. You had dy dx, some px into y, etc. We introduced that so that the entire things become exact. Okay, it becomes exact, so that it can be ddx of something, the product of y into if. These things are called exact differentials. Okay, so if you look at this one, x dy plus y dx, whenever you have this form, it can be d of xy. Look, the product, just product form to apply kor. This is, keep this x constant, you have dy, keep this y constant, you have dx. So whenever you have this, you can write this as d of xy. So this is the total differential of this one. So clearly when you integrate, you will simply get xy. So this is the idea behind exact differentials. Now the point is, most of the times what you have as your problems in your examinations, you have variable separation, you have homogeneous equations, or reducible to those forms, similarly for linear, etc. So sometimes what happens is you go on and apply different kinds of things, and you see what's going on. Okay, it's difficult and all the steps, but if you know the idea of exact differentials, sometimes things can be written very easily to a particular format that we want, because at the end of the day, it's all about integrating and finding out the original relation between x and y, and getting rid of dy dx and all those things. Okay, so this is what we are going to do here. Look at some of the forms. Mostly what happens is we use these three forms. Okay, I have listed the rest of it because again you can use that, but nevertheless যদি আমরা use করি, I will talk about it. But look at these things that we use. We normally use this product form and the quotient form. ঠিক আছে, আর যদি কিছু use করি, I will talk to you about it. Look at the quotient form here. If you remember the u by v method that we normally do for quotient rule, so this is x, which is the denominator, into dy minus y into dx divided by x square. Okay, so sometimes you also have this part looking the same thing. Okay, looking like the same thing here, just along with a negative sign. But here you have denominator as this, here you have denominator as this one. So accordingly you will understand whether you will have x by y or y by x. So these are the three formulas that we are mostly going to use. If you just look at the rest of the things written here, they're very simple, but we don't use them often. Mostly 18 lage. ঠিক আছে? So let's just see one example so that you understand what's going on. All right. So again, as you can see, we have a lot of things going on here. You have x dx, y dy, etc. তো জানিস এটাকে আমি যদি integrate করি, this is very easy to integrate. This is also very easy to integrate because this will give you like x square by 2. This is giving you y square by 2. These things are very easy to integrate. আমি যদি তোকে বলি x dx টা integrate করে দে, তবে কোনো প্রবলেম নেই। y dy টা integrate করে দে, কোনো প্রবলেম নেই। So what we try to do is we manipulate the rest of the things in such a way that somewhere down the line I can write it down as d of something, so that on integration I just simply have that particular thing. So that is the idea behind exact differential equations. So look at some of the things here. Look at the format. This is one format that we are already very aware of. This format is something that we actually used for the quotient form, the numerator of the quotient form. So let's try and use exact differentials here and see what we can do. Okay, first of all, this is a direct formula I have used here. This is tan inverse y by x. This is d of tan inverse y by x. Let me just go back to the previous slide so that you understand. Just 1 minute. Edek. D of tan inverse y by x. X by y you have y by x, depending on what kind of thing you have here, whether you have x dy minus y dx, etc. So as you understand, for tan inverse something, so for tan inverse z, we have 1 by z square, right? This is what we have. Fair enough. So but since we have this as x by y, so apart from this denominator being 1 by x square plus y square, here I'm going to need the differentiation of x by y. What is that differentiation? The differentiation is very, very simple. Y dx minus x dy divided by y square. So in the numerator, I need the differentiation. So as you can see, this y square will get cancelled. This is x square plus y square. Here you have this. So once you understand these patterns, then you will understand the rest of the things better. Okay, just let me just give you one simple idea here. Clearly, as you can see here, it's very simple. X square plus y square you have here. So you know that this will be from tan inverse something. If you have x plus y in the denominator, you know that this is from logarithm. And also once you have this, somewhere down the line you understand that this got generated from the differentiation of some quotient function. So try and identify the quotient function. So first we are integrating dy. This is the differentiation we have taken. So normally we take the numerator first. So this is of the form x by y. Sorry, y by x. Okay. So I hope you understand this. So I can write this as, let's just see this pattern. Can I write it as this, x dy? No, this can be difficult, but try and understand the idea behind it so that it's going to be clear. I'm introducing this x square. You know that these things got generated. Sometimes what happens is, একটা জিনিস একটু দেখার চেষ্টা কর. How do I understand that this is d of this? The first thing that comes to my mind is, if you remember this format is something that I'm absolutely familiar with. X dy minus y dx. You know that this comes for some sort of quotient. So what is the quotient? The quotient is, the first thing that is kept constant is basically the denominator, and the first differentiation that we have taken here is the numerator. So for this quotient, I also need this x square. Fair enough? So since I have used this x square here, so somewhere down the line, I need to divide this by x square as well. So if I divide this by x square, this is y square by x square. Can you see the pattern now? This is very crucial. If I put this as z, look at this. If I put this as z, this is actually dz. So you have dz by 1 plus z square, which is actually tan inverse z. So this is the idea behind exact differential equations. Now the best part is, since you know this is d of tan inverse y by x, and this part is very simple because this is going to give you x square by 2, this is giving you y square by 2. So if you integrate, simply this is what you're going to have. Okay, so this is the idea behind exact differential equations. There are some format that will help you out to reduce down your steps, or the methods that you normally use, the complicated algorithms and things. Okay, let me just show you another example. Some basic adjustments, and this is something we are going to have. You don't have to worry about this because I'm sure you can take care of this. Some basic manipulations about inverse trigonometric functions, etc. So don't worry, just concentrate on this part. Okay, let's take a couple of more examples. তারপরেও যদি বুঝতে অসুবিধা হয়, I will help you out. So just try and understand the essence of this theory. All right. Look at some of the things that we are having here. So this part is very crucial, that you understand that, okay, I see some pattern and I understand that maybe somewhere down the line, I can use some of the things that, that's for exact differential equation. Look at what we are doing here. This is what I have done. Fair enough? Because you have this y dx and x dy. This part will actually indicate that, all right, I know that somewhere down the line, there's something going on which is of this portion. Fair enough. Now look at this that we have written here. It's very crucial. I have introduced x square on both the sides. Okay. So this is x cubed dx. We know that I don't need y to the power 4 here. Whatever be the quotient, I will require this. So what I have done is, I have taken this y square, but I don't need this y alone. I have to have something of this form again. so that I can substitute something, and this is the d of that. So basically the idea is to have a substitution which is backed up by its differentiation, something I have talked to you about for a long time now, that I understand the reason behind the substitution. See, this is very, very crucial that you understand that this is what we are having here. If you have any trouble up to this portion, please let me know. First of all, try and understand the part which tells you that yes, this is prone to the particular thing we use for exact differential equations. This is the first thing that you need to understand. Once you understand that, the next thing that comes to your mind is I have y dx minus x dy. Fair enough? How do I write this step? Okay, I have y dx minus x dy. Okay, so this is the numerator, this is the denominator. So I need to have y squared here, so that this is d of x by y. Now what is the problem? The problem is I have y to the power 4. So I need y square. Since I'm taking y square here, the numerator cannot be left alone. I again need to express this as a function of x by y, because there's a backup of the derivative of x by y. So that is why I'm taking x square by y square, so that I can write it as x by y whole square. All right. So that's why we have introduced x square here. Now it's looking much better. Integrate this. This is so simple, x to the power 4 by 4. Look at this one. If I substitute this as z, if this is z, this is the backup dz. That's the best part about these kind of things. So this is actually z square, which is z cube by 3 on integration. So do you see this? So this is actually z cube by 3. So it's so simple. Looks very complicated. It does not really match any of the categories that you have talked about, be it the linear differential equation or Bernoulli's or anything like the homogeneous, etc. Or sometimes even if you have the form, using exact differential will actually help you save some time. So I hope this is okay with all of you. But if you still have any problems, please let me know. But make sure you understand that, okay, this is the pattern that I have seen, that, okay, this tells you that, fair enough, maybe I can do some adjustment and use the exact differential thing. So try and understand what we need to introduce. So just adjust that properly and get the solution. Okay. And so this is the solution that we are going to get, and that's it. Let's take another example. So it's looking a little complicated, don't know what's going on. There are a lot of things and don't know how to express this. But let's just see some basic thing here. You know that somewhere down the line, e to the power x itself is repetitive when you are differentiating it. So if you look at these two things, you have y e to the power x dx and e to the power x dy. This is very simple. Look at this part. So it's more of like when you take the quotient or whatever, what you do is normally you keep the denominator constant, you take the numerator and its differentiation. Then what you normally do is you keep this constant and you take this. So it's very simple. You know that this is the pattern we are looking for. Okay, so denominator constant, numerator gets differentiated, minus numerator is constant, denominator gets differentiated. So you know that at the end of the day, this will be your numerator and this is going to be your denominator. So first you try and understand this format. Once you know that this is going to be your denominator, the first thing that comes to your mind is, I need this y square here for the backup. So this will tell you that the next adjustment will be this. Now look, this is so simple, but you need to find out the particular pattern. If you look at all the sums, it can look a little complicated, but if you understand the essence and you see deeply, you will clearly see the procedures we are following. Every time we are doing any adjustment, what we are looking for, what we are dividing the entire thing with, you will clearly see some correspondence going on. So practice more and more sums. Now, if you just integrate this is so simple. The first one is x cubed by 3, and the next one is, sorry, this is e to the power x by y. Okay, that's it. Very simple and elegant, but with some basic changes here and there and some adjustment, and using this exact differential equation, you can definitely solve this. All right. If you guys have any problems regarding this, please let me know. I know it's complicated, but try and understand the steps and the reason behind the steps. And আমি তো এখানে অঙ্কটা করে দিচ্ছি, but তুই যখন অঙ্কটা গিয়ে করবি and you don't know how you will approach the sum, so these are the signals you need to look out for. So this is a classic, product or quotient form. So you know what you actually need. So adjust that accordingly. Okay. All right. So that was all about it from exact differential equations. Very, very crucial. So you need that concept for two things. First of all, you will see some problems where none of the methods that you have learned so far will work. And as a matter of fact, you really need to use exact differential equation. And secondly, sometimes you will see that by using exact differential equations, exact differentials, you can actually reduce the kind of steps you need to do for different other algorithms. Okay. So I'm going on to the next concept, which is applications of differential equations. Now this part is very crucial, and you will get tons of sums from different types of, places, be it economics or physics or anything. Okay, you will get statistics, you will get different types of things where you will actually land into some differential equation, and then you need to solve them. Once you talk about differential equations, what do we have? We have the rate of change, dy dx. What does it represent? It represents the rate of change, right? So whenever you talk about any real life situation, you are talking about any rate of change, which is very, very important for all the different types of things. You land into differential equations. So it's only fair that we try and see some applications and understand how we can use the solving methods for differential equations for those kind of sums. All right. Okay. A population grows at the rate. Now look at this, at the rate of 5% per year. You know that whenever the population is growing, it's a function of time. So you have two functions here. You have the population, you have the time. So the rate of growth. So there comes the idea of differentiation. So you know that somewhere down the line, using the conditions that we have here, we are going to find out a differential equation that we are going to solve. So this is the first line. The second line is, how long does it take for the population to just get doubled up? So we are going to use differential equation for this. So let's get started. তোরা এই টাইপের সামস অলরেডি করেছিস বিভিন্ন কেমিস্ট্রিতেও, তোরা যখন মানে হাফ লাইফ এগুলো রেডিওঅ্যাক্টিভ ডিকে বা এগুলো করিস, তোরা অ্যাপ্লিকেশন অফ ডিফারেন্সিয়াল ইকুয়েশন কিছুটা করেওছিস। So we are going to use these kind of things for different types of sums, because for application of derivatives, we have seen that derivatives are introduced for rate measures, are introduced for tangent, normal, and so many things. Okay, and sometimes they have their applications in physics, where you learn about velocity, acceleration, and all those things. So let's see what we are going to do here. All right, population. So what we have done here is, so the population needs to double up. So I need to have an initial population so that we know that what happens when it doubles up. So suppose the initial population is 2 P0, and after t years the population is P. So obviously P will be a function of t. So P is the dependent variable, t is the independent variable. Then this is what we are going to use. Look at this, the rate of growth. So what is the rate of change? That is dp/dt. So there comes the application, sorry, there comes the significance of derivative. That is 5% per year. So 5% is like 5 by 100 into p. So this is so simple. Eto baje baje differential equation আমরা করেছি, like they're very very complicated. You see that, but when you apply them, the differential equations are not that complicated. So it's very simple. Do some basic variable separation, and this is what you're going to have. Okay, so this is the first part of the sum. We have formed a differential equation because it involves rate of change of something, and now we have a basic relation between p and t, barring the basic dy dx type of terms. Okay, so we have eliminated the differential coefficients, and now I have this relation ln p equals to t by 20 plus c. This is what you have. Fair enough. Now what is the basic thing here? You understand p in terms of t. Now how long does it take for the population to double up is very simple. So at t equals to 0, okay, p was p0. So what we are going to do is, for all the cases, we are going to try and find out the c, because this is still unknown. So I'm going to find out this c so that we have a clear indication of the original relation between the population and time. Let's put all the values here. So I'm putting p equals to 0 and p equals to p0. So this is something we have done, the boundary condition or the initial value problem. You remember initial value problem? See, you clearly understand initially at t equals to 0, p was p0. Using that, I am finding out the value of c. Fair enough. If you guys have any problems regarding this part, please let me know. I have used this basic thing here to form the equation and then solve it. So I'm done with this. Now there's a constant which is yet to be evaluated. This is actually still a parameter. So I need a particular value. So for that, I'm using this initial condition. All right. So now we have something which is way more sorted. Clearly, there is a relation between population at time t, the time t itself, and some constant, which is the initial population. Fair enough. Now comes the second part of that. How long does it take for the population to double up? So t is this. Simple. I'm taking ln p0 to this side. So this is ln p minus p0, which is division, and again 20 will be taken to this side. Now I need, for the time, I need p equals to 2p0 because it's getting doubled up. So what will be t? You put the values, and this is what you're going to have. Okay, so number of years or whatever the time, this 20 ln 2 years. I hope this is okay with all of you. If you still have any doubts, please let me know. Yeah, it can be a little complicated, but if you remember, if you understand the steps here properly, it will be easy. Okay, so again, application of derivatives, we saw that the significance of derivatives is like the rate of change. We have talked about derivative as a rate measure. So obviously when you actually form the linear differential equations here, you can definitely go ahead and solve that. Let me take another example. Slope. First of all, forget about the rest of the sum. The slope of the tangent, but that's it. এইটুকু পড়লেই তুই বুঝতে পারবি slope of the tangent is nothing but dy dx. Again, you see, you will have some sort of equation that will involve dy dx. It is a differential equation. You need to solve this because you find out the equation of the curve. For the equation of the curve, you have a relation between y and x. You don't have dy dx. So even before you start the sum, You know that there's some sort of, importance of dy dx here, but again, you need to get rid of that and come back to the most basic thing, which is the relation between x and y. Simple. What is the slope of the tangent? The slope of the tangent is dy dx. Fair enough. The slope of the tangent is dy dx, which is given as minus x by y. So this is your required differential equation. Now, if you look at this, you have seen so, so much complications in differential equations. This is very, very simple. I can write it as y dy equals to minus x dx. So some integration, and this is what you're going to get. So as you can understand, solving the differential equation, even for the last case or here, it's very simple variable separation. So it's not going to be very complicated. But unlike the previous cases where you had the differential equation in the first place, here you need to form the differential equation and then solve it. Okay. So this is the first step. You form the differential equation from the given condition. The second step is you solve the differential equation. Now, what is this? This is a general solution. I need a particular solution. So what do I use? This part is already used. Okay, the slope is whatever. Now the curve passes through the point this. Now this is very, very crucial. What is this? This is a circle. This is a family of circles. So once you fix a point, you will get a particular member of the family, which will give you the equation of the curve. So let's find out the value of C. So what is the given condition here? It passes through 3 comma minus 4. So you can get the value of 2C or C, whatever is convenient. So this is what you're going to get. Okay. So make sure you understand each and every step. They're not very difficult. You know what tangent is, and then that is equals to minus x by y, and that's it. Okay. But also make sure you understand that apart from forming the differential equation and solving it, it will give you the general thing, of course. Make sure you get the value of the constant so that you find out the particular curve. আরেকটা sum করছি. Okay. Now it's looking a little complicated as compared to the previous things. Find the curves for which the portion of the tangent included between the coordinate axis is bisected at the point of contact. So let's not go into the sum. Let's not, form the differential equation right away. Just try and understand what is meant. Suppose this is a curve. You have a tangent here. What is the length of the tangent included between the coordinate axis? This is the part where it's between the coordinate axis. So this is the part. So it is getting bisected at the point of contact. So this will be same as this one. So even before you move on to the original sum, try and understand what we are going to find out. Because while forming the differential equation, you're using a lot of, your previous knowledge about tangents, point of contacts, coordinate axis system, or bisection, midpoint. You're going to use a lot of the things. So make sure you understand this properly. Let me tell you a basic idea about this method. Suppose you have a point of contact xy. You know the equation of tangent you already know. So you can find out these 2 points because at the end of the day, it is basically a straight line. So from the intercept form, you know these 2 points. You know the midpoint with the midpoint formula. That is nothing but x comma y. Okay. So before we move on to the original thing, if this is not clear, feel free to ask. And if you want to wait for the entire, sum to be completed to see whether you understand when we do the sum or not, you can also do that. Anything that's convenient. So let's get inside the, algorithm that we are going to use here. I'm taking p, x, y being any point on the curve. So what do I need? I need the equation of the tangent. This is the equation of the tangent. Y minus y equals to m into x minus x. We are using this capital X and Y as the current coordinate system. So this is the equation of the tangent where m is dy dx, which is the slope of the tangent. ठीक है? I have taken this point of contact x comma y and I have seen that this is the basic equation of the tangent. Now, I have the equation of the tangent, right? Equation of the tangent ami peye gelam. This is a straight line. What do I need? I need these 2 points because the midpoint is nothing but the point of contact because it is getting bisected. So what I need is these 2 points. So let's find out these 2 points. So point gulo ki hobe? Eta or eta. Now your question can be, how do I directly write this? So let me just show you something. This point is of the form alpha comma 0, right? This A point is of the form alpha comma 0. To get this point, what you do is, since this is x-axis, look, I'm putting capital Y equals to 0. If I put capital Y equals to 0, you can clearly see that this x, capital X will be mx minus y by m. Fair enough? Jodi kono problem thake, please let me know. Just let me show you one simple trick here. So suppose you have ax plus by equals to c. Okay, so suppose you are going to need this point. Just put y equals to 0. So x will be actually c by a, which is nothing but the intercept. Okay, so even if you don't want to write this as an intercept form and then find out the coordinates, no problem. Just put capital Y equals to 0. That will give you this point. Put capital X equals to 0. That is going to give you this point. Very simple. Okay, so first you have the equation of the tangent. Then you have the coordinates of those points where it's actually intersecting this. ঠিক আছে? তাহলে এই পয়েন্ট দুটো পেয়ে গেছি। What is the next thing? It's getting bisected at the point of contact. So what is the point of contact here? This is actually x comma y. All right. The point of contact, it's a middle point. So this plus this divided by 2 is actually x. So this is what I'm using here. You can use the other part as well, but it's not going to be, it can be the same thing. So here, very simple. Look at this. So simple. You know that m is nothing but dy dx, and this is how you form the differential equation. Okay. If you have any problems regarding this segment, please let me know. It's not very difficult, but just try and understand what we have done here. So yeah. ঠিক আছে? ভালো করে এটা দেখে নে। Okay. So P is the middle point of A and B. So this plus this divided by 2 is x. So this is the differential equation. Some basic adjustments we have done here. Take this m to the side, etc. So this is what we have. All right. Very, very simple integration. And this is the curve. ঠিক আছে? If you remember this is actually a rectangular hyperbola. And when I started with the diagram, even before we move on to the sum, this is the diagram I started with, so that you people can understand this. ठीक আছে? If you have any problems regarding this, please let me know. This is one of the classic types of sums you encounter during the application of differential equations. So we'll do a few more sums with tangents, etc., because you know the slope of the tangent will give you dy dx. All right, so let's move on. If you still have any problems regarding the previous one, please let me know, and don't hesitate, because it requires a lot of other concepts and the basic knowledge about the concepts as well. But look at each and every step carefully, because it will actually have different types of concepts going on, but they should be okay. Okay, আবার ঘুরে ফিরে কি বলছে tangent at any point on a curve. Forget about the rest of the things. We'll talk about the rest of the things. Tangent at any point on a curve. So you know that whenever you talk about tangents, it's again going to give you some sort of terms regarding dy dx. Okay. So basically you have a tangent on any point on a curve. So you know the equation of the tangent. So you draw the tangent. Suppose this is the tangent. You actually find out the perpendicular distance from 0, 0. So perpendicular distance from origin. This distance is same as the abscissa of the point of contact. So if the point of contact is x comma y, the abscissa is x, so it's going to be same as x. Okay, so let's just see what we can do here. Very similar to the previous one because the concept is similar. So tangent, this is tangent, fair enough. So what I'm going to do is I'm going to write the tangent in this form. If you remember that, if I have this particular equation of the straight line, okay, so what is the distance from 0, 0? The distance is c by root over a square plus b square along with a mod sign. Okay, bhalo kore dekhe ne what we are doing here. Before you find out the distance from the origin, the perpendicular distance from the origin, it needs to be actually represented in this way. So that's what I have done. This is something into capital X plus something into capital Y plus a constant equals to 0. So what will be the distance from this? The distance will be y minus mx because this is acting as the constant here. As you can clearly see, this is the constant here, divided by root over m square plus minus 1 square. Okay, so this is the distance, perpendicular distance from origin. It is same as the abscissa of the point of contact. So can you see this? This is the point of contact. Okay, now it's looking much better. What I'm going to do is I'm going to take this to the side and square both the sides. So as you can clearly see that this is what we are going to get. This is y minus mx whole square equals to x square into 1 plus m square. Now you will see that this m square x square will get cancelled and this is what you're going to get. Looking much better. This is simply nothing but a homogeneous differential equation. Make sure you understand that m is dy dx. Okay, bhalo kore calculation gulo dekhe ne. If you have any problems that I can help you out with, let me know. So this is what you have. So the value of m, which happens to be dy dx, is y square minus x square divided by 2xy. All right. Okay, so this is a homogeneous differential equation. So acha ei equation ta age likhe ne. The equation is y square minus x square divided by 2xy because I'm going to solve this. So what is the equation? The equation is y square minus x square divided by 2xy. As I have told you that whatever differential equations you get here, they're not very difficult to solve, but to find out, to form the differential equation, you need different types of concepts, be it any coordinate geometry oriented, any condition or any other thing, rate of change or any other significance of derivative. Make sure you understand these things properly. So very simple. So this is what you're going to have. Okay, now as you can see that this is the general solution. You have to find out the curve, this particular thing, find out the equation of the curve satisfying the above condition, which is the general thing, which passes through 1, 1. Now this is very crucial. If I use this fact that it passes through 1, 1, I'm going to get the particular value of c. Okay, so this is what I'm going to get, because look at this. If x equals to 1 and y equals to 1, all right, then v will also be 1. So I can put v equals to 1, I can put this equals to 1. So it's very, very simple. This part won't contribute because this is ln 1. So ln C will be ln 2 because I'm putting V equals to 1 as well. So C will be 2. So put the values here, and this is what you're going to get. This is not very difficult because this is actually V square plus 1 into X equals to C. So this is the basic idea here. You just take this to the side and remove the logarithm. This is the basic thing you get. It passes to 1 comma 1, so C will be 2. Now put the value of V back, which is Y by X, and that's it. This is your required equation. Okay. So if you guys have any problems regarding this, feel free to let me know. This was actually a family of circles, and you found out the circle which passes through 1 comma 1. ठीक है? So as you understand that the formation is not very difficult if you know the basic knowledge about the rate of change or tangent normal or coordinate geometry, the initial things about coordinate geometry properly, and also solve them. It's difficult because it requires a lot of steps, which in turn require a lot of concepts going on, but the rest is fairly simple. So if you have any problems, let me know. And otherwise, I'm moving on to the last part, the last concept of today's class, which is differential equations of second order. Okay, differential equation of second order. So this is the form. You can have different formats of differential equation of second order, but in this case, I'm only going to use this particular format and learn how we can use this. So if you remember when we were forming differential equations, if you had two parameters, so you differentiated twice, right, to get that parameter, just to eliminate that parameter or those parameters, and then you get first order equation or second order equation. So you differentiate twice. Fair enough. So when you come back to the original thing, you need to integrate twice. So what we are going to do is we are going to integrate it once, because d2y dx2 is d dx of dy dx. So I'm integrating this. This is dy dx is c. I mean first bar itake integrate korlam. This is the first integration. So we integrated again. So suppose on integration, this is going to give you capital Fx plus C1. C1 is a constant. So you integrate that again, and this is what you're going to get. Okay, so the algorithm is fairly simple. Let me just show you one simple sum so that you have a very clear idea of what's going on. At a simple sum kori, otota mane algorithm to bishon simple. You're going to differentiate, integrate it twice. So this is dy dx, all right, d2y dx. So for dy dx, you need to integrate it. So look at this part. This is very simple. This is d dx of dy dx is this. So dy dx will be, you integrate this. What is the integration here? This is ln x. This is 6x plus c1. So this is the first constant of integration. Fair enough? Now you have something that you're already familiar with. You have this dy dx going on. It's like, very good. I need to integrate it again, which will give me y. Y equals to integration this. Now ln x is very simple to integrate. You will have x ln x minus x. You can absolutely go for the integration by parts. So this is actually ln x into 1. So first function, second function, normally how you treat this. Again, you see that at the end of the day, you need to integrate. So go ahead and practice what you have already done for integration. So this is what we are going to do here. Once we understand this, the rest is fairly simple because this is 3x squared. Now look at one thing. This is C1. So C1x will be there on integration because here we have dx. And again, you have the second constant of integration. Now, the beauty of this process is this will actually tell you that while forming the differential equation, you had two parameters which you eliminated, and that is why you got a second degree equation. And here when you just integrate that back and get rid of the differential coefficient, which is d2y dx2, you can clearly see that here you are having two parameters. Okay, so the order and the number of parameters, how simply they are related, and also the formation or solution, either you're differentiating and you're forming it by eliminating the parameters, or you are integrating it or finding out the solution by eliminating the differential coefficients and introducing the parameters. Try and understand both the ways so that you have a very clear knowledge of differential equations. So finally, some basic algebraic manipulation, because these two are like terms. So I have taken the x common and that's it. Okay, let's just do one more sum here. Okay, again, the idea is very, very simple. d2y dx2 is a function of fx. Sorry, it's a function of x. So it's of the form d2y dx2 equals to fx. Integrate it once. So this is the first integration. Again, as you can clearly see, I'm going to apply integration by parts. Not very difficult at all. This is what you're going to get. Okay, apply integration by parts. So take x as the first function, cos x as the second function. You can clearly see that this is what you're going to get after integration. Integrate it again, and this is what you're going to get. So cos x is pretty easy because this is going to give you sin x. This is going to give you c1x. You will have another c2. For this one, again, I'm going to use integration by parts. Okay, so that's it. Some basic adjustments, and this is what you have. The only pressure point for this sum is, for both the cases, you need to integrate. And here, there's nothing much from the differential equations point of view, just the basic understanding of how they are formed or how you can come back to the solution. So you need to integrate. So whatever you have done for integration, go ahead and practice that. This is the last sum we have, and after that I'm going to move on to the class exercise. So this is the last sum we have here. If you guys have any problems regarding this, you can absolutely let me know, because I hope you have understood after 2 sessions of differential equation that the concept of integration is absolutely necessary here. So we have seen some basic antiderivative method, we have seen some substitution, by parts, partial fractions, or any other things that we normally use. So go ahead and revise them. You're going to need it here, you're going to need it for definite integration even before you put on the values. You need it for differential equation, you need it for area under the curves. So absolutely important. With this, I complete all the things we had to learn about the topics in calculus, and this is just August, so I hope it will give you ample time to go ahead and practice the calculus things, because that carries a lot of weightage in your board exam as well as any other exams. So that's it. Let's move on to the class exercises. ठीक है? Class exercise, I'm going to do some mixed sums, and then we'll see how we can proceed and see some mixed sums and understand that this is the thing I need to look out for these kind of things. So let's get started. The first one is fairly simple. Gx is a differentiable function. You have to find out the solution of this differential equation. Again, you see this, dy, you see the gx, g dash x. So as you can clearly understand that there's this function, there's a backup of its, derivative. So you know that somewhere down the line, with some adjustment, you're trying to find it out in such a portion, in such a pattern that you already know. Now this is something we are doing here. So I have written this as dy dx plus g dash x into y equals to gx into g dash x. So as you can clearly understand that this is a linear equation, a linear differential equation of first order. Okay, so this is a function of x. Divide x into a function of x into y equals to another function of x. Fair enough? If you guys have any problems regarding this part, let me know. First of all, just do some basic adjustments and look at this from the point of view of a linear DE. Integrating factor. Integrating factor is e to the power integration of this particular function dx. Okay, so this is g dash x. So on integration, this will give you gx. Just the simple antiderivative method. All right. So what will be the solution of this? The solution will be y into integrating factor equals to whatever was originally here. Along with that, see, I have used this. All right. Put the values here. So we are sorted with the LHS. Now I'm going to talk to you about the integration on the RHS. Now you have e to the power something, then this something is also here, and also there's a backup of its derivative that will come from the chain rule. So you know that it's going to be very simple. Let's just put gx equals to z. I have written it directly. Let me just show you the steps here. Let's just put gx equals to z. All right. So g dash x dx will be dz. Fair enough. Gx is z and this is e to the power z. So you know what do we get from this one? We get z e to the power z minus z. So put the value of z, which is gx, so you can clearly see what's going on. All right. So this part is very, very crucial. I have told you that for differential equations or linear differential equations, for IF as well as the last step, the RHS of the last step, in both the cases, you're going to need integration. So make sure you revise that. Basic adjustments here, I have taken this e to the power gx to the other side, and this is what you're going to get. All right. So this was the first question. Fairly simple. Just one change here and you have a linear D and it's good to go. So let's move on to the next one. See, if you still have any doubts, we can always come back and discuss about it, so don't worry. The problem with complicated sums is that you don't see the structure right away. Okay, so once we do the theory part and we talk about some solved example, you know that this is the theory, this is the algorithm, this is the particular pattern I'm supposed to look out for. But when you have mixture of sums, it's very important that you understand the kind of adjustments we are going to do here. Look, this is what I have written. Okay, simple. Now, do you see some of the things that I have already told you to look out for on different types of equations? You have sine theta, you have cos theta. So somewhere down the line, you know that apart from whatever functions you have in terms of x or d theta dx or anything, so it is actually some sort of the form where it's reducible to linear DE. This is very, very important that you actually understand the particular type here. This is linear differential equation, reducible to linear differential equation actually. All right. So what I'm going to do is very simple. Look at this. This is dy dx. I mean d theta dx. Just for the time being, let's just look at this from the general perspective. Function of x, fair enough. Function of x, khub bhalo. Problem is this. Normally we have this, theta here, but here you have a function of theta. No problem. I have the backup of the derivative. So this will actually tell you that go for the substitution so that sine theta d theta dx will give you du dx. You see the essence? This will actually tell you that go for that substitution that we use for Bernoulli's equation. So this is what it reduces down to. Now it's very simple. It's a linear differential equation. So you find out the integrating factor. All right. So integrating factor is very, very simple. This is px. If you compare with the original form, this is px. So this is what we are doing here. It's just integrating this. This is x squared. This is ln x. Look at this. What is this? E to the power x squared. Since there's a subtraction of the quotient, so I can write it as this. Okay, this is something we can write. Now e to the power ln x is nothing but x. So I hope you understand the integrating factor here. As I have told you that for linear DE, you have to integrate. For the IF, you have to integrate for the last step as well. What will be the solution? Look at this thing. I have written it directly, but the steps are visible. But look at each and everything. The solution is this. The solution is U into IF. I'm sorted with this part. Let's look at this part. This, okay, into this. All right, fair enough. So you have x e to the power x square. Fine. So e to the power something, and there's a backup of that thing. So suppose I have 2x here along with a half. So this is actually of the form e to the power z, and that is why you have this e to the power z again. Okay, try and understand all these things properly. If you have any trouble, please let me know. And also make sure you put the value of u, because you introduce that for your own benefit so that it gets reduced down to something that we are already familiar with. But if you don't understand that, make sure you see the substitution properly and also put back the value, because the original variables were theta and x. So this was the second sum. I hope this is okay with all of you. Still, if you want me to repeat anything, feel free to ask. So don't worry. I know that these things are little, not little, they're kind of complicated, because you exactly don't know what things will be there, which you can just apply directly. But nevertheless, see some good examples so that you form a good idea of what you need to apply. Third one. All right. So the problem is, you see a lot of linear things going on, but somewhere down the line you knew that you had this a1x plus b1y plus c equals to 0 and all those things. But here the type is very similar. Look at this. Previously you had linear by linear. Here you have a quadratic by another quadratic. That is the basic thing, right? So for these kind of things, the first thing that comes to your mind is, what if I can reduce it to something which is homogeneous? Just look at one thing. এটাকে একটু ভেঙে লেখ. You have x squared plus 2xy plus y squared. Okay. Here you have xy minus 2x plus 2y minus 4. So look at this one. This is second degree. This part is also second degree, but there's some problem with this one. So somewhere down the line, if it is possible that it is of the form xy, which is simply second degree linear homogeneous equation, then all our problems will be sorted. Let me tell you something. This is not some sort of linear by linear form so that you can compare the ratio and you go for the rest of the things, but you understand the essence. Why did we do the substitution? Because we wanted to reduce it down to something homogeneous. Look, let me just show you a very simple adjustment here. Can I write this? Yes. This is x plus y, so this is x plus 2 plus y minus 2. Put these two things. I'm putting x equals to x plus 2 and y equals to y minus 2. Do you see the transformation? Is this homogeneous? The answer is yes. So what I actually want you people to understand is, apart from the form, apart from the condition, okay, this is the pattern, so blindly apply the substitution. No, understand the reason behind the substitution. Reducible to homogeneous, it means that there's something that is causing some trouble in the homogeneity. What are those things? What happens when I use the homogeneity here? আমার এটা নিয়ে কোনো problem নেই, this is perfectly okay. আমার এটা নিয়ে প্রবলেম আছে, if I just have this kind of thing, it's perfectly sorted. So let's just try and see the corresponding homogeneous thing, and accordingly I am going to put the substitution. Okay, the substitution is not something which is very visible, or you see the pattern, but you understand the reason behind it and you're sorted. The rest is very, very simple, because it's simply homogeneous differential equations. So I'm going to put y equals to vx. So this is what we are going to have. I'm moving on to the next slide. Okay, so some basic adjustments, and this is what you're going to have. All right, so make sure you understand these things, because once you get the homogeneous differential equation, the rest will be pretty simple. So you don't have to worry about those things. I'm sure you'll be able to work that one out, and it will be a good exercise for you to practice homogeneous differential equation as well. But don't just blindly follow the structure. Keep an open mind, and whatever idea you're using behind the substitution, why you're using the substitution, you understand that thing. So the depth of your knowledge is tested for these kind of sums. Okay, so if you guys have any problems regarding this one, please let me know. I'm not going through the calculations, because you people are absolutely intelligent enough to figure this out, because we have already done this. Some basic substitution, variable separation, and integration. Okay, but capital X, capital Y, V, whatever we have introduced here was for our own benefit. So make sure you put back the values. It is very, very crucial for subjective exams. For objective exams, obviously you will have options, so that you have a clear idea of which one is supposed to be chosen. But for subjective exams, make sure you come back to the original variables. So fourth exercise, again, as you can clearly see, a lot of things going on, like y by x, sine, cos, etc. So let's see what we can do here. All right, look at this, something we have written here. You have sine of x by y, right? When you think about integrating sine of something, you know that sine of something will give you cos of something. Fair enough. But chain rule tells you that if this is not simply x or simply z, or whatever single variable you are considering, make sure there's a good backup of its derivative. Now what we have done here is very simple. I have just taken sine x by y to one portion, cos x y by x to another portion, and some sort of dx and dy. These two terms are very, very simple to integrate. So just 1 minute, okay? You look at the calculation, just give me 1 minute. All right, so if you look at this thing, which is very simple, you have sine of something or cos of something. These things are very easy to integrate, because sine of something will give you minus cos of that thing. But unfortunately, it is not sine x or sine z or something simpler. So you have to get a backup of this x by y or y by x. So as you can clearly see that, if you look at this part, What is this? Y dx minus x dy. Fair enough. So good backup for this one. Yes, this is d of x by y. You see cos of y by x. You see the backup? Yes, the backup is there. So apparently, which looked like something, looked like a nightmare, if you just understand the idea of this thing, the backup of the derivative that I have told you like so many times, you know that this is so easy to integrate. You have sine of something backed up by its derivative, cos of something backed up by its derivative. The last two things are very, very simple. So you integrate that. Sine of x by y along with its derivative will give you minus cos of x by y. Similarly, cos of y by x will give you sine of y by x. You don't have to worry about anything else because there are differentiation of these functions here. So that's it. Okay. So I hope this is okay with all of you. Still have any doubts? Feel free to let me know and I will help you out with this. Cool. So let's move on to the next sum. Okay. Again, the first thing that comes to your mind is y by x. This is very, very crucial. This is the first thing that comes to your mind. I have something like y by x, and trust me, there's no way you can control this, because cos of y by x maximum you can do some substitution. So whenever you do the substitution, you have to go for the backup of its derivative. You cannot do anything with cos of y by x. So our idea will be to try and find out the derivative of y by x. So there's a good backup and I can use some substitution or directly write down whatever I want to write down. So see what I have done here. Very simple. Y by x, right? So what will be the backup? The backup will be x dy minus y dx divided by x square. So what should be the backup for this one? It will be x dy minus y dx divided by x square. And I cannot control this part. So I need to find out this part. So I can almost see this, but I need some adjustments which can be easily taken care of. Look at this one. Okay. So I have taken this to the denominator here. Good backup of its derivative in the numerator, which is the one thing. Since I have this x square in the denominator, it has to be adjusted with x cube here. So just writing this so that you people understand it better. Okay, so take this dx and x cube to the other side, and this is what you're going to have. Fair enough? So I hope you understand that why all of a sudden, what will give me the clue? আমি কিছুই বুঝতে পারছি না কি মানে এত বিচ্ছিরি দেখতে জিনিসপত্র কিছুই বুঝতে পারছি না. So try and find out the backup of the derivative because you have some sort of things going on here, x dy, y dx, etc. Look at this. This is d of y by x. That is the beauty of this one. I'm integrating both the sides. This is very easy to integrate. It's a function of y by x along with the backup of its derivative. Understand the essence and that's it. You're sorted. Don't have to worry about the complicated sums. So 1 plus cos theta, right? 1 plus cos theta, we don't know how to treat this, but I can write this as 2 cos square theta by 2. All right, I can write this 1 plus cos theta. Suppose this is of the form 1 plus cos theta. That can be written as 2 cos square theta by 2. ঠিক আছে? তাহলে আমি এটা লিখে ফেললাম. So this is cos square y by 2x along with there's this 2. All right. So the next thing is very simple. This is sec square y by 2x along with d of y by x. Kono problem nahi. This is just an extra constant that can be taken care of. When you integrate, this is what you're going to have. Sec square something along with its backup. It's going to give you tan of that thing. But since you have this, 2 here, So it's going to be divided by half. So this is getting cancelled. Very, very simple. And this is absolutely simple because this is x to the power minus 3. And that's it, you have your answer. Okay, so make sure you understand the essence of this differential equations, exact differentials, because for both the cases, if you notice that you saw that even in the previous case, I cannot control y by x, I cannot control sine of x by y. So let's look for the derivative, and so that we can use exact differential equations. Fair enough? Chalo. Let's do the next sum then. All right. The next sum is very, similar to what we have done for applications of differential equations. Again, you see that tangent. So when you talk about tangent, you understand that you talk about dy dx. So find the equation of the curve, which is such that the area of the rectangle constructed on the abscissa of any point and the intercept of the tangent at this point on the y-axis is equal to 4. Now, when you think about the entire thing, it looks very complicated. So let me start with the most simple thing, which is the equation of the tangent. So this is the equation of the tangent. Okay, look, I'm sorted with this part. All right. Now let me concentrate on this. Intercept on the y-axis. What is intercept on the y-axis? Whenever you consider anything for intercept on the y-axis, this is what you need to find out. So if this is 0, beta, then beta is nothing but this intercept on the y-axis. For that, what we do is we put the x coordinate as 0. Okay, so just put this as 0. So this is gone. So what is capital Y? That is the y-intercept is y minus x dy dx. You don't have to go for the intercept form. You don't have to find out the intercept. Just try and use the basic thing. This is the y-axis, right? So you put just x equals to 0. You get the point. This is the y-intercept. Now, কি বলে দিয়েছে? Area. Area কি নিয়েছি? আমি এটা নিয়েছি. And I have taken the abscissa at the point. So rectangle constructed on these two things. So length and breadth we get. So this is the area. Area will be mod x into y minus x dy dx equals to 4. I hope you understand this. And we have taken this modular sign because you don't know whether the intercept will be positive or negative, or I don't know how the point of contact will be. So I hope this is okay with all of you. Now what I have found out is this area. I have equated it to 4 and I'm done with this. All right. Now you have your differential equation. Now this differential equation is looking very well because it's simply a linear DE of first order. You can clearly see you have dy dx, some function of x into y equals to another function of x. So you find out integrating factor. Again, integrating factor tao ekhane bhishon easy. The integrating factor is this because this is working as px. All right. This is working as px, so this is the integrating factor. What will be the solution? Look at the solution here. The solution will be y into integrating factor equals to plus minus ta jemon ache thak 4 by x square into 1 by x. So this is 4 by x cube. All right. So integrate this. X cube will give you x to the power minus 2 divided by minus 2. So some basic adjustments, and this is the curve. So initially it might look very, very complicated, but try and understand each and every, portion of the sum, and I'm sure you will be sorted. ঠিক আছে? If you face any problems regarding this, then please let me know. I can definitely help you out with this. I know there can be some complicated things going on, but don't worry. If you practice and understand the idea behind the theory, you'll be sorted. Okay, now this is one complicated sum, because the formation of the differential equation will require some basic knowledge. But let me tell you that if you understand the idea, it's very simple, and you will actually have these kind of problems, very repetitively. You will see these kind of problems, and especially on many occasions for JEE advanced and these kind of exams where you have passage based questions, you have some sort of things of this particular type. So make sure you understand what's going on. Basically, once you understand this, you know that somewhere down the line I need to form the differential equation and I need to solve the differential equation, right? So let's form the differential equation. A tank initially contains 100 liters of brine in which 50 grams of salt is dissolved. So initially you have the volume as 100 liter. V at t equals to 0. You have 100 liters of brine and 50 grams of salt. Okay? যেখানে বুঝতে পারবি না any step, just ask whether there's some sort of problem going on, and I can help you out with that. So I'm done with the first line. So there's this brine containing 2 grams per liter of salt runs into the tank at the rate of 5 liter per minute. So this is the flow which is coming in. So what is this? This is 2 gram per liter. This is the concentration of salt, and rate of flow is 5 liter per minute. All right. So as you can clearly understand that 10 gram of salt is coming per minute. Okay. So if you just understand this, 5 liter per minute, and per liter you have 2 grams of salt. So this is the basic input of salt. Now this is getting mixed. Done. The mixture is kept stirring and flows out of the tank. Now let's just use the third line. It flows out of the tank at a rate of 4 liters per minute. So 4 liters per minute. Okay, this is a flow. So what I need here is this part. So how many grams of salt per liter? This is something I want to know, to try and understand what is something I know and what is something I need to figure out. Because there was initially some sort of things, it's getting mixtured with some of the other things, and then it's just getting pumped out. So whatever flow is there after the mixture of them, mixture is going on, then you will understand the basic things. We have to form the differential equation of the process and solve it to find an expression. Now this is very important, because at the end of the day you need to understand what are the variables between which you are finding out the relation. Amount of salt present at time t. Okay, because this is what I said, that at time t whatever salt will be present is very, very important, because that will also control the rate of outflow. Okay, because I need this, how much salt is going out. I hope this is clear, and if you see the formation now, it will be very simple, because you understand what's going on. The first thing is the rate at which salt is added, that is 10 grams per minute, that is the inflow. So you have 2 grams per liter and 5 liter per minute. So I'm sorted with that. Now Vt is the volume of the brine at time t. So initially you had 100 liters. Okay, at time t you have 5 liter coming in and 4 liters going out. Fair enough. So this is at time t, this is the volume. So try and understand each and every step. If you don't understand any step, you can let me know. This is a very, very crucial sum, and you will see similar types of sums everywhere, especially for difficult passage based questions. So this is the volume. rate of at which the salt leaves. Now this is very important because at the end of the day, you're finding out the expression of the amount of salt present at time t. This is very, very crucial. So you need to find out rate at which salt is leaving. Now for that salt, when it's leaving, you know that this is outflow rate 4 liter per minute. So I have this. But what I don't have, I have this part for that outflow, but I don't have this part. Like, how much is this? Like gram per liter. I hope you understand that we don't have this part. So how do I get this concentration? You know that at time t, the volume is this. The brine, the mixture here, the volume is this, and the amount of salt is this. I hope this is okay with all of you. The rate at which the salt leaves is this. The salt enters, you know the concentration of the salt, you know the rate of flow. Here you know the rate of flow, but you don't know the concentration of the salt. So how will you find out the concentration of the salt? That will be the volume at time t, and in the numerator you will have salt at time t. Fair enough? So salt at time t is y, which is something we are supposed to find out, and volume we have already found out. So what is the rate of, the salt leaving? Obviously, originally this was 10. This is 10 gram per minute. And here this is the incoming, and the outgoing is this. So this is the rate of change. I hope you understand this. If you don't, please let me know. This is the addition, this is the subtraction. So this was the incoming thing, and obviously there's this outgoing. So that difference will give you the change. Okay. So now that we have found out how to, actually form this linear differential equation, you can clearly see that this is a linear differential equation, and it will be very, very easy to solve. So don't worry about the rest of the things. First of all, understand whether you are actually, get this part of the entire sum or not, because I know it can be a little difficult, but you will have different types of sums of this particular form. So that's it. ठीक है? So it's a linear differential equation of first order. So you know how to solve it. You have to find out the integrating factor. Now look at this. The integrating factor, what is this? This is actually the contributor of this integrating factor. So this is the integrating factor. Fair enough, very simple. So what will be the solution? The solution is very simple. Y into this, okay, equals to, we are sorted with the LHS. Look at the RHS, this one. All right, ठीक है? So 10 was initially there, and this is the integrating factor. So this is not very difficult. I have directly written this, but let me just tell you the steps here. What is this? Let me integrate. So this is actually 100 plus t to the power 5 by 5. So this is actually 2 into 100 plus t to the power 5. Okay, plus c. Fair enough? If you look at this step, which is directly written here, you understand that, okay, if I divide this by 100 plus t to the power 4, I understand the first part. So obviously there has been some sort of value of c that has been determined. I hope you understand what I'm talking about. So understand this thing. There has been some value of t. What is this? This was like 2 into 100 plus t. এই ক্যালকুলেশন গুলো কিন্তু তোরা নিজে একটুখানি হাতে কর, নইলে কিন্তু পরে কিছু বুঝতে পারবি না। ক্যালকুলেশন গুলো কর। So I need the value of c. So if you remember, in all these things that we have used here, this part is something I have not used yet. This part is something that we haven't used yet. Have we? No. Initially, at t equals to 0, What was the amount of salt? The amount was salt was 50 grams. So this will give you the value of C. I hope you understand what I'm talking about. This will give you the value of C. Put T equals to 0. Okay, if I put T equals to 0, then Y equals to 50 grams. So 50 into, I'm putting T equals to 0 here, right? 100 to the power 4 equals to 2 into 100 to the power 5 plus C. So C এর value কত হবে? This. If you actually find this out, you can take this 100 to the power 4 common. So you will have minus 150 into 100 to the power 4. Okay, put the value of C, divide the entire equation by 100 plus T to the power 4. This is what you're going to get. I know this is complicated, but don't worry. আজকে অনেকটা টাইম লেগে গেল, অলরেডি 12টা বেজে গেছে, but it's okay. Last day আমাদের অনেক আগে শেষ হয়ে গেছিল. So it's okay, it can vary because sometimes we have difficult types of sums and they take time, so it's okay. But make sure তোদের concentration ইয়ে করবে, কখনো যদি break লাগে, you people can let me know if you need a break. Sometimes the classes are extended, 3 ঘন্টা জায়গায় একটু বেশি হয়ে যায় এদিক ওদিক. But what I want you people to do is to understand everything and take some inspiration from here, so that you understand the essence of the theory beyond the just calculation or just application of the algorithm. ঠিক আছে, এই সামটাতে কোনো প্রবলেম থাকলে let me know. I know it's a little difficult and kind of lengthy, but try and understand each step and you'll be sorted. Now that you are lucky that this bad bichchiri ekdom joghono example is over, sorry, you have something worse coming up. So it's only logical that we are talking about differential equations and applications of derivatives, and so we talk about some physics things. So let's talk about retardation and acceleration and all those things, velocity. Now it's looking very bad here, but let me tell you that it's not that bad. So a cyclist is moving on a level road at 4 meters per second. So there was this velocity going on, right? So he just stops pedaling and lets the wheel come to rest. So obviously there will be a retardation and it will come to rest. So this retardation has two components. The first one is constant due to the friction, okay? And the next one is actually dependent on this V, some sort of things going on here. So it's a function of V, and also there's a constant thing. Okay, so there's a constant friction, resistance, retardation due to friction, and also there's a resistance with this particular thing involved. So before it comes to rest, you have to figure out the distance it's going to travel. Now this part is very, very crucial, because at the end of the day, you need to find out the distance, and it also involves V, okay, which is the velocity. So these are the two things you need to actually take into account. So the first thing that comes to your mind is acceleration is this and velocity is this, okay? So V is dx dt, all right? So this is the distance. And acceleration, well, we are going to talk about the retardation, so obviously I'm just going to take the negative value. It's perfectly okay. So this is d2x dt2, because this is ddt of dx dt. So you know that acceleration can alternatively be written as this, because I can actually break this part as d dt of dx dt, and some basic manipulation will give you this. Not very difficult, so try and understand how we can write this one. Okay, some basic chain rule and you'll be sorted. All right, so A is actually, if you don't understand the step, you can let me know. A is actually dv dt. So just try and understand what's going on, so I can use some basic things. I can write this as dv dx into dx dt. Okay. So this dx dt is v. This is something you're going to need for your problems in physics as well. Acceleration, apart from this second order differential coefficient, I can also write it as v dv dx. Now, how does it help me, and why we are talking about this particular format is very, very important. Distance traversed by the y cycle. Now this is very, very important. At the end of the day, I am going to need distance. So whatever formation of differential equation is there, make sure you actually keep this particular variable. Fair enough? So আমি কি কি ভেরিয়েবল রেখেছি, v রেখেছি আর x রেখেছি, because again we are going to talk about speed, because there's this retardation where there's an influence of v, and also we need the distance. Now by hypothesis, this is what I'm going to write. Very simple. Retardation এর দুটো component রয়েছে. Okay, so this is the retardation, v dv dx. You remember, we can write acceleration in this part. I'm just using a negative sign here because it's retardation, so I'm going to use a negative sign. All right, so look at this. It's very, very simple. Variable separation, absolutely simple. So if you just understand up to this portion, if you just use the basic logics here of rate of change of velocity or rate of change of distance, etc., you will understand that this is very, very simple. Next part. Now this next part is very, very crucial, because normally what we do is we go for the indefinite integration, and then what we do is we find out the value of c. So sometimes instead of doing that, we go for definite integration. Okay, so you know that the difference between indefinite and definite integration is we have some sort of limits going on. So how will I give the limits here? Very important. Look at this one. So the variable separation is pretty obvious. So I have the limits of x, I have the limits of v. Initially at x equals to 0, okay, so at x equals to 0, which was the initial portion where it started it actually stopped pedaling. So this was 4. Okay, and finally when v is 0, it comes to rest. You have to find out the distance that it has traversed. So understand that in the limits, this is the variable. So this part is very important, that you understand the limits properly. Look at the limits here. The lower limit is 0. The corresponding v is 4. The upper limit is x dash. So after after just traveling this distance, it just stops. So obviously the v is 0. Okay. One more thing, as you can see the adjustment here, I have 4 plus v square. So for that, we have taken this 2v here so that there's a good backup of the derivative. And as a result, I have multiplied 2 here. The rest is fairly simple. This is x dash. So this is ln 4 plus v square, 0 to 4, and absolutely simple. Just put the values here. Suppose I'm taking this as plus. So this is 4, and this is becoming 0. All right. So what is this? I put 4, I get ln 20 minus I put 0, I get ln 4. So log a minus log b will give you log of a by b, which is ln 5. Now it tells you that you are in the right track, because as you can clearly see, the value of ln 5 is given. So this will be 1.61 divided by, you already had the 0.04. So some basic, calculations of decimal, and this is what you're going to get. ঠিক আছে? If you guys have any trouble regarding this, please let me know. I know it's not little complicated. It is complicated because there's so many concepts going on. But if I can help you out with any steps, then don't hesitate. All right. Okay. Orthogonal trajectories of this family of curves. Okay, first of all, family of curves and their orthogonal trajectories. You don't need to worry about anything. Just understand that whenever you have some orthogonal things going on, their slope will have the product -1. So suppose this is the family. So let me just find out the basic differential equation of this family. Okay. So differential equation is very simple because there's just one parameter. So I just differentiate it here, and sorry, this is Cx. Okay. So I put the value, and eliminating C, I get this differential equation. Fair enough. Let me repeat. So you have this family of curves. You have to find out the orthogonal trajectory of this family of curves. You know that suppose you are considering two straight lines. The first one has the slope dy dx. What will be the slope of its perpendicular line? This will be minus dx dy. This is very, very crucial. Always understand that whenever this is the basic trajectory you're talking about, for orthogonal trajectory, this will be the slope, so that the product is -1. All right. So এখানে আমি কি করব? It's very simple. I'm going to find out the differential equation for this one so that I have the value of dy dx, and for the orthogonal trajectory I'm going to take the same thing as minus dx dy. Okay, so this is something we get after eliminating c. So this is dy dx. Fair enough. So some simple adjustments. I'm taking this 2x to the other side and some division and subtraction. This is dy dx. For the orthogonal trajectory, I have to replace dy dx by minus dx dy. So if I just put minus dx dy here, there will be some changes, and this is what I'm going to get. Fair enough. So this is the orthogonal trajectory. This is a homogeneous differential equation. And if you just solve it, you will get this. X square plus y square equals to ky. I hope this is okay with all of you. If you still have any doubts regarding this, please let me know. Know that this is complicated, but don't worry. Look at the idea of this. Every time you talk about orthogonality, the product of the slopes will be -1. So you have dy dx here. That will be minus dx dy in the orthogonal trajectory. All right. So make sure you understand this. And every time, now this is very crucial, every time whatever you do as the initial steps, you're coming back to, linear DE or first order, from where you are integrating and finding out the IF and then integrating again on the RHS, or you find out the homogeneous homogeneous differential equation or variable separation. You have to integrate them. So go ahead and practice. Final sum, এটা তোদের homework দিলাম. Just write it down. This is very interesting. If you don't get the answer, you can come back the next day and we'll talk about it. ঠিক আছে? That's it from today's class. আজকে আর class quiz করতে হবে না. Just short করে revise করে দিচ্ছি কি কি করেছি. I'll just talk to you about the summary here. So basically, the first form is very crucial. You know that if they are not equal, we are going to go for the substitution x equals to x plus h and y equals to y plus k, which will reduce it down to homogeneous differential equation. And if they are same, then we are going to put one of them as v, so that you have the variable separation form. The format but what we reduce it down into is different. And then we talked about linear differential equation of first order, which is very, very important. And this is mostly, you will see this present for different types of competitive exam. This part is absolutely necessary. Also remember the alternative form. Sometimes we don't care about the alternative form here, but if nothing works, make sure you check this one out. Reducible to linear form, we have talked about Bernoulli's equation, and don't just strictly stick to the basic structure of Bernoulli's equation. Make sure you understand the essence, and sometimes you don't have this y to the power 1 minus n or y to the power minus n. You have cos x, sin x, or e to the power x, e to the power x, or these kind of things. So make sure you understand that. Exact differentials was one of the difficult most thing that we have done today. But if you understand the idea behind it, you will actually see the things properly. And we are also using some product form and quotient form of differentiation here, so revise that. And finally, second order was very, very simple because you need to differentiate twice. But for both the integrate twice, but for both the integrations, make sure you use this C1 and C2 because this is second order. I'm going to have two parameters here. So that's it from today's class, and we'll conduct the class quiz someday else because aajke already onekta deri hoye geche. So if you have missed out on anything that you want me to repeat, feel free to ask. And otherwise, I'm done with today's class. Anything that you want me to repeat or any questions? So it was quite complicated, some of the sums that we did here or concepts that we talked about. They were complicated. তো বাড়ি গিয়ে যা যা আজকে করে দিয়েছি বলেছি সেগুলো একবার একটুখানি রিভাইজ কর, and if you see some problems anywhere that you're stuck at, আমাকে পরের দিন জানিয়ে দিস. I'll help you out. Okay, so that's it. If you want to stay for any other problems, you can do that, or we're officially done with today's class. I'm going to see you on next Sunday.